Hey guys, Connor here with the Motion Visual. I've got tons of Spline videos and tutorials up on this channel already with some deep dives into lots of aspects of the program. I've tried starting a complete guide to Spline series a few times but never really got there. Today I'm making it happen. This step-by-step guide will take you through everything I know about the program. I've created all the videos you're seeing right now in Spline. I love this program because for me, Blender or Cinema 4D was overwhelming and held me back as I got lost in the weeds with technical controls and could never reach that creative flow state that artists talk about. Spline may not have everything Blender has to offer, but for me as an artist, it provides me the freedom to create like no software ever has. It's so much easier to create amazing things in this program than many realize. I'm confident the developers at Spline are constantly working hard to make this experience even more magical, and so I'm all in on Spline. Like I said, I've got tons of lessons already, but if you're a beginner looking to seriously take full advantage of this program, congratulations, you're where you need to be. Hit the like and subscribe buttons for me if this guide is something you'd like to see fulfilled. Ask any questions in the comments, I'll answer all of them. I teach one-on-one Spline Zoom lessons as well, just so you know, but let's skip the nonsense today and get right into this. Spline is a free program to use and download. Go to spline.com and hit get started. Make an account, you can download the program or use it in your web browser. Click New File up top, and you're ready to go. Click anywhere in the dark area to get rid of this menu you see, and then click the gray square and hit Delete. That line you see in the middle represents the lighting of your scene. In the left, you'll see directional light in the black box. This left box will be a list of all the objects in your Spline scene. The right box has a ton of features to control everything, and we'll slowly learn all about it. But first, let's look for the word Scene in the right and click the gray box next to Background or Background Color. Click it to open a color menu. Pick a color like this blue. Look, much better already. Now if you look in the top menu, you'll see an icon of a cube. We're going to create your first 3D object now. Click the cube. Now hold Shift and click anywhere in your background and drag down and to the right. Holding Shift ensures that your cube will have equal proportions on all three axes. The axes are titled X, Y, and Z, and they represent side to side, up and down, and back and forth respectively. If you look right now, you'll see the menu has changed. You'll see settings for position, scale, and rotation. This represents the properties of your new cube. Right-click the cube and select Reset Position. This perfectly centers your cube in your scene. You'll notice all the position numbers are now set to 0. Now click in your background again and deselect your cube. Press and hold Alt on your keyboard and click and hold your mouse in the background. As you move your mouse around, you'll notice you're changing your perspective of the cube and your scene in general. As you can see, the light from the top right is lighting your cube while the other sides of it are in more darkness. Now check out the bottom menu. This little red, blue, and green cross represents your perspective. If you hover your mouse down there and click Reset, it will center your perspective again for you. On the other side, if you click Isometric, you'll get a diagonal view of your scene. If you scroll your mouse back and forth, you'll zoom in and out on your cube. And if you click your scroll wheel and move the mouse, you can move around back and forth in the scene. This is how you move about the 3D space in Spline. The orthographic setting gives you a mathematically precise view, while the perspective setting will give you a realistic, lifelike perspective. Click your cube again and go to the right menu where it says Material and click the gray box next to the word Color. You can recolor your cube here. There's a ton of incredible materials to learn about that we'll get into the future, but for now, you've learned a little about all the menus, how to create your first object, and how to navigate an interface of Spline in 3D. Awesome. We're going to end the first lesson here, but don't worry, lesson 2 is coming right away, and it's likely already available for 99% of you. Before moving on, practice using the Alt-Click Rotate, Scroll Zoom, and Scroll-Click techniques to get really familiar with moving around the 3D scene. This is going to be super important. Consider it your homework, and I'll see you in lesson 2. Thanks so much for hitting the like and subscribe buttons for me. It's going to be the difference maker on whether I can complete this whole guide for you guys, so sincerely, thank you. I'm Connor, this is the Motion Visual, and hopefully I'll be seeing a lot more of you. Till next time, peace. Hey guys, Connor here with the Motion Visual. Welcome back to Spline, the complete guide. This is lesson 1.2, creating, moving, and editing shapes and objects. Hopefully you've seen lesson 1 and are comfortable moving around the 3D space. Today we're learning about creating 3D shapes and objects and changing their characteristics. Here we have our cube from the last video. Just like we learned to move, scale, and rotate our perspective, we can do the same thing to our objects. Click on your cube. The red, blue, and green controls you see do 3 unique changes to your objects. Each color represents an axis. For example, if you click this blue arrow, it moves your cube back and forth on the z-axis. If you click this blue curve, you can rotate your cube on that same z-axis. Finally, clicking this blue circle allows you to scale your object on the z-axis. Click Ctrl-Z quickly to undo all your actions, and now try doing the same thing while holding Shift. This allows you to scale all 3 dimensions together equally. Shift will also allow you to rotate your shapes in precise increments. Again, to reset your actions, you can click Ctrl-Z to undo each step. These settings can all be changed in another way. You can type them into the settings shown on the right side. If you want to rotate the cube 45 degrees, you can just type in 45 into one axis. The little lock button next to the scale setting acts like the shift control and keeps the settings relative to each other. This is how you edit the position, scale, and rotation of your objects. Above this, you'll see the words viewport, state, and events. These all have to do with animating in Spline, and we'll learn about them in another lesson. Beneath this, you have the snap settings. This makes it easier to move and create objects in precise increments. We'll also check that out later. Next, you have your size settings. Size works similarly to scale, but sometimes it's important to keep your scale settings even and adjust the sizes instead. Next, the side setting, which doesn't affect a cube, but affects changes in the amounts of the sides on shapes like diamonds or hexagons. Corner affects your shapes and edges. As you can see, if you set it to 0, you get a perfect cube with right angles, and the higher number you get, the more round curves you get on the edges of your shapes. The corner sides set how many faces make up this curve. Smooth and edit is how you begin 3D modeling, which will have its own lesson as well. Next, you have your material settings. Materials will be a whole set of lessons coming in its own chapter of this guide. We won't do too much now, but try changing the number of your lighting material to see how it changes the way lighting reveals your shape. We've already learned how to change the color. This number up top is the opacity of your shape, and when it goes to 0, your shape becomes invisible. Next, the align to path setting, something we'll learn about later. And beneath this, you have visibility. The wireframe setting shows you the faces and vertices of the geometry of your objects. The flat setting will change your rounded vision to reveal the geometry and the flat surfaces that create them. Try adjusting the corner sides again. You can see the flat edges on your shape. And finally, sides shows you the front, back, or inside and outside of your shape, or both of them together. Next, the shadow options decide whether your object casts shadows onto others and whether it receives them. This will be revealed when you have multiple objects in your scene. Beneath this, we have the cloner setting. The cloner is a special feature which multiplies or repeats a specific central item in different ways. You can see examples of these different ways by changing the options in the type drop-down menu. It's a good way to duplicate things you've built in Spline so that you don't have to repeat the steps. It repeats all aspects and animations in grids, lines, or circles depending on your settings. You can also randomize these patterns based on settings in the randomness section below. The cloner will get its own lesson, but you can try experimenting with the different settings to get familiar with it. In fact, you should do that with all the sections that we've learned about in this right menu box today. We'll save collision for another lesson as well. The right-hand menu is crucial to your ability to create your visions in Spline. For your homework today, practice with positioning, scaling, and rotating your cube in your scene, and mess around with all the options in the right-hand menu while your cube is selected. See how these changes affect your scene in different ways. Remember, you can hit the Ctrl-Z to undo all your actions in succession. Next time, we'll be making all sorts of shapes and seeing how the different settings affect them as well. That's all for lesson 1.2. Thanks for being here. Please hit like and subscribe if you want to see the next lesson, and I'll see you guys at the next time. Thanks for tuning in. Peace. This is lesson 1.3, creating, changing, and editing 2D and 3D shapes, paths, text, and more. In the first 2 lessons, we learned how to move around 3D space, adjust and edit our 3D objects, and got a good introduction to the settings in the right menu and how they affect our objects. Today, we're going to make a bunch of unique objects and learn how to adjust them as well and about all their individual characteristics. In the top menu, the first option on the left is this plus sign. This is how you add so many things to your Spline scene. Not only can you choose from a wide variety of 2D and 3D shapes, but you can add different types of lighting, text, interactive features, and cameras, which offer different perspectives of your scene. Click this plus sign and scroll down to the pentagon option and select it. The 5 shapes in this section are all different 2D shape options that you can choose from. Hold Shift Click and drag to create your pentagon. Let's make it a more fun color real quick. Now if you adjust the side settings, you can change your shape to a hexagon or an octagon or other random agon shapes. The corner setting rounds the angles or the corners of your shape. If you rotate your perspective, you'll see that 2D objects are only visible from one side and not the other. By increasing the extrusion setting, you'll turn your 2D shape into a 3D shape with increasing height. Pretty cool. The bevel setting is like the corner setting, but it adjusts the new 3D dimension on this shape. Bevel sides adjust how many faces there are in a corner of the bevel. If you go to your flat visibility setting, these faces will reveal themselves. This brings me to an important point. Everything in your 3D scene are created using points and lines and flat faces. These points are all plotted to specific XYZ spots in space. Round curves are only implied in 3D, but don't actually exist in technical truth. The wireframe visibility settings will show you this by piercing the veil. Now change all your settings to their lowest point and hit the edit button. These little blue dots that appear can be selected and moved around to make unique and weird shapes. You can delete these points as well. Soon we'll learn how to add points and draw our own shapes using them. Undo this with Ctrl-Z and try Convert to Path. Change the size settings and you'll see your shape has now become a path or an outline of the shape based on these points. Paths can be used in many cool ways. You can delete the pentagon by hitting delete or backspace. Try pausing this video really quickly and experimenting with the other 5 flat shapes in this section. Try making a 5-pointed star and changing it into a 4-sided flat diamond shape. See what other angle and inner settings do. Check out the unique settings for each shape. Above the flat shapes, you'll see AI Generate and Library. You can use Spline to generate 3D objects using an AI prompt. It's pretty wonky and still in beta form, but it's fun to experiment with. The library has a whole collection of 3D objects you can choose from and add to your scene. You can pause and try experimenting with these as well. The AI generator is pay to play, but Spline lets you try it out a few times for free. Next, we have UI, input, text, and path. UI and input are interactive objects used for making apps and websites. We'll skip them for now. Try selecting text. Click and drag to place it and try typing something. Text acts just like the flat 2D shapes. You can change the size, font, color, and more, and similarly extrude it and convert it to its own shape. This is a fun tool to mess around with and another thing you should take some time to explore. Now select path. Click in the top left, right, then bottom right, middle, bottom left of your screen to draw a path. Shape setting changes the shape of the tube of your path. The size will change its diameter. The ring setting will create a hollow middle or tube inside your path. Angle cuts out sections of the diameter and side sets how many faces the diameter has. Depth and offset will shorten your path from the start and finish respectively. Angle rotates your shape while twist twists it. Start and end scale will adjust the diameter on each side of your path. If you delete your path and try drawing another, you can connect or complete your path into a loop by joining the final point back to the first one. Up top, if you select the arrow button, you can select the points and move them around, but try alt-clicking to rotate your perspective. Now you can move these points around in 3D space as well. Now click this curve button on the right side. Click a point and drag your mouse away. This is how you turn angles into curves in your path. The little purple balls that appear adjust each side of these curves. Before you delete your path, try making a small sphere. Remember the align to path setting we skipped in lesson 1.2? Click that to align your sphere to your path. If you change the slider offset settings, you'll notice the sphere stays aligned to this path now and moves around it like a track. Pretty cool. Let's try something else real quick. Go over to your path in the left-hand menu and click the little eyeball that appears. This makes your path invisible. Now click your sphere again and try changing the slide and offset settings. It moves along on an invisible path now. This will be useful creating awesome animations in the future. Next, we have particle emitter and particle force. These are two awesome features that will let you create things like smoke, rain, glitter, wind, vortexes, fire, dust, galaxy, water, rivers, and so much more. I'm skipping them for now because they're awesome and they deserve their own chapter, which will come very soon. Next, we have plane and backdrop, which are just flat surfaces. And finally, we have our 3D shapes. Let's try making them all. Cube, sphere, cylinder, torus, helix, cone, pyramid, dodecahedron, icosahedron, and the incredible torus knot. Each of these has their own unique set of settings and characteristics. I could go through all of them with you, but I want you guys to learn this app in the best way possible, and right now that's by doing and not hearing. Adjust your light so that you can see all your shapes well. Go through each of them and mess with all their settings. For example, look what you can do to the helix over here with its unique settings, or the torus knot. It creates all these awesome 3D geometries. Before I go, we're going to learn one new material. Click one of your shapes and hit the drop-down box next to color and select normal. Normal is a colorful material setting that comes from normal maps, which are a color-based 3D topography. Each color and shade represents a different angle in 3D space. Pink on the right, blue on the left, green on the top, and purple on the bottom. Normal maps are used in a lot of fun ways in the 3D world, and it helps you see your shapes better. I'm signing out for now, but this lesson isn't over for you. Go through each shape and learn all the ways you can edit and change them. More importantly, learn how you can stack and compound these changes in unique ways. Adjust the size, scale, corners, rotation, position, sides, colors, lighting, and unique settings for each shape. The more you know about what you can do with these basic shapes, the better you'll be and more able to create incredible, complex objects very soon. This is lesson 1.4, Intro to Animation, Events, States, and Transitions. Welcome to the 4th lesson. I hope you did your homework. Usually you can skip it, but if you skipped it this time, do it now. Learn to edit your shapes. Also, don't forget, learn to edit your shapes. Today we're going to learn how to create your first animations in Spline. Each aspect of your shapes that can be edited can be animated. So the more you know how to do, the cooler animations you're going to be able to make. So the last thing before we continue, learn to edit your shapes. All right, let's start the lesson. Start a new file, create a cool background color, and create a helix. You do know how to do that, right? Reset the position to center your helix. Increase the path radius to fatten it up, and set the revolutions to about 3. Get it looking similar to what mine does. It doesn't have to be exact, but if you do want it to be exact, you can copy my settings and type them in. Select your helix. Remember the state and event sections we skipped in lesson 2? We're going to learn about them now. Click the plus sign next to the word states. The words base state and state should appear in a list below. With state selected in blue, move your helix up on the y-axis about 200 points. Now rotate your helix on the y-axis left about -500 points. If you didn't know this, instead of using the controls in the center, you can place your mouse over the left side of the light gray settings boxes. A double-sided arrow will appear, and you can use this to change your settings up and down by moving left and right. Now click base state again. The position and rotation settings should all be 0. Click back to state, and the 200 and -500 should still be there. Now click the plus sign next to events. The word start should appear with a list next to it. Click transition on the top, and then click transition again to open up the settings. Change the word current to base state in number 1. Number 2 should read state already. Now change the number 1 in this box to 5. Once you're done, click play at the top. Congrats, what you're watching is your first animation. Now you're probably thinking, okay, I did that, but I have no idea what just happened. Let's break it down. In Spline, states are versions of the same object in different forms. These different forms are created by changing the settings of an object while different states are selected. Events are just that, things that happen. There are dozens and dozens of different styles of events. Some are transitions, some are interactive, some react to things like gravity simulations or collisions with other objects. The event you just made is a transition. It's the most common form of animation in Spline, at least for me personally. In Spline, animations are much different than traditional animating, where artists have to change the image step by step or frame by frame. The way transition animations work in Spline all has to do with the states. The animations are created automatically by transitioning between the settings of the states that you created. In this case, the helix is animated to rise up and rotate because those are the settings that we changed between base state and state. The 5 that we entered is the number of seconds that the animation takes to happen. Now, let's open your transition again and select loop and set it to infinite. Below, select cycle and select ping pong. Hit play again. Now your animation is set to continue endlessly. This is what loop means. The ping pong setting has it go from start to finish and then back from finish to start, or from base state to state and then state back to base state, and so on. If you didn't have this ping pong setting on, the loop would make it skip to the bottom each time. Now open your transition again and try changing the ease in out setting to linear, like this. This makes your animation move in a consistent speed instead of starting and ending each transition by speeding up and slowing down. You'll notice it abruptly changes directions at the top and bottom now. Let's try a new animation. Create a sphere and give it a color. Now add a new state and change the color. Hold Shift and change the scale of the sphere to be bigger in state as well. Add a transition event again, make it 3 seconds long, set the loop to infinite, and cycle to ping pong again, and hit play. Now you'll see your sphere is animated to grow and change colors. Both animations you just made so far are compound animations because they each have 2 different animations happening in one, 2 different settings changing. The helix spins and rises, the sphere grows and changes color. We skipped right over simple animations where only one thing changes. My bad. But you guys are getting good at this, and I think you'll be okay. As you can imagine, a more simple animation would only have one change. Now let's try adding another state to your sphere. State 2 should appear. Change your sphere to a 3rd color and increase its scale again. Try moving it down. Now this is 3 changes happening. Open your transition again, add state 2 to the list by clicking the plus sign next to the word transition. Set the number 1 to 3 and press play. Now your sphere is cycling from base state to state, and then from state to state 2, back in reverse to state, and back to base state again. You can add endless states to your transitions to add multiple animations to each object. I shouldn't be doing this in this lesson, but I know you guys might be proud of your animations and want to add them to your Instagram or your TikTok. Does me saying Instagram first make me sound old? Let me know in the comments. My dad likes to call it my face. Click your background, then click the drop-down menu next to the word frame. Select TikTok from the drop-down list. A box will appear. This is the box that your video will be the shape in. Click your animation you want to save in a video and click the eyeball next to the other one to hide it. Hit play and make sure it looks good. Now hit export, select video recording, change the M bits to 120 for the best quality, change manual to fixed, and choose how long you want your video to be. Hit start below, then hit the red record button. When it's done, save your file like any other, find it on your computer, right-click it, hit share, airdrop, and make sure your phone is unlocked and send it over. Can't believe I taught you guys that, shame on me. For your homework, practice making all kinds of animations of different shapes by changing all sorts of different settings. Some settings can be animated and some can't. Try to learn which ones those are. Make some more TikToks, I guess. Animations will be an entire chapter of this guide in the future, but that's the basics of animations for you. Now you have all the tools to make a ton of different animations using all the different settings and all your different shapes that you know. Learn to edit your shapes. Next lesson will be an introduction to either 3D modeling or materials. You guys can vote on which ones you prefer by letting me know in the comments below. Winner goes first. This is lesson 1.5, Intro to 3D Modeling, Part 1. Faces, edges, and points. 3D modeling is the process of constructing or building 3D objects that will make up the essence of your 3D world. I'll be the first to admit that Spline in its current form is not exactly the industry standard when it comes to 3D modeling. That being said, Spline does have a decent variety of awesome tools for building and modeling in 3D, and their team is constantly updating and rolling out new features on a regular basis. Okay, start a new Spline file. Set a fun background color, and make a perfect cube. Reset its position, give it a cool color as well. Turn its lighting all the way up in materials. This will help you see the edges of the shape better. Turn the corner and corner side settings all the way down so you have a perfect cube. Adjust your view to isometric, and now with your cube selected, click the Smooth and Edit button. You'll see it turns into this crappy looking ball shape, kind of like a soccer ball from Nintendo 64. This is from the Subdivision modifier, which we'll learn about more in the next lesson. But essentially, it turns your flat and angled geometry into finer and finer curves. In terms of the subdivision modifier, a perfect cube and a perfect sphere are the same thing on opposite ends of a spectrum. As you turn it up, you'll get a more and more perfect sphere, and as you set it to 0, you'll get a perfect cube. Set it to 0 for now. You'll notice your top menu has changed. On the left side of the menu is a set of 3 cubes. These options are the face, edge, and point or vertex options respectively. Each one of these settings allows you to select those aspects of your shapes. Try clicking one side of your cube. Instead of your whole shape being selected, now only this specific side or face of your cube is selected. The face, edge, and points of your cube can all be adjusted in the same way that the shapes or perspectives can be adjusted in Spline. They can be moved, scaled, and rotated. Using the controls that you're already familiar with, you'll notice that you're able to move your face up and down, back and forth, or left and right. The same is true for rotating this face. You can twist, skew, and slant the face in respect to the rest of the shape, which stays anchored and unchanged. Next, you'll see you can scale your face to be wider or thinner, taller or shorter, and then you'll notice the last scale control doesn't seem to do anything. Try holding Shift. Now you'll notice that the whole face is scaled to be larger or smaller with consistency. Finally, these little gray circles in the middle allow you to grab and move your face in all directions in 3D space at once. This makes me realize I may have forgotten to teach you guys this in lesson 2. These gray circles allow you to move your shapes around in 3D space as well. Sorry, I'm doing my best here. Okay, now try selecting the edge option and clicking this top edge. The same controls will rotate, scale, and move your edge. Try experimenting with them all and seeing how Shift affects each control. You can see as I rotate, scale, and move this edge around. Last, we have our point or vertex control. With only one point selected, Move is the only control that will have any effect. This brings us to our next step. Select the face option again. Now select one face, then hold Shift and select another adjacent face. Now you have 2 faces selected. With your controls, you'll be moving, scaling, and rotating both of these faces together now. So get comfortable controlling 2 faces at a time. Now do the same with 2 adjacent edges selected. See the different shapes that you can make. Now try selecting 2 points and doing the same. You'll notice selecting 2 points on the same line is equivalent to having the edge that connects them selected. Try selecting 3 points and see what this does. Now try this. Select one point on a cube, Alt-click to rotate your perspective, and Shift-click the opposite corner point. Now see what happens as you rotate, scale, and move these points together. Pause this video and go back and do the same thing with multiple faces and edges and points selected. Try grouping selections that are adjacent or next to each other. Try selecting faces, points, and edges that are opposite of each other. Try selecting different amounts, 2, 3, 4 points, edges, and faces, and see how rotate, scale, and move changes each time with these different things selected. When we selected these opposite points, we were able to make weird and wonky shapes. But when we select opposite faces and try to scale them, you'll notice the entire cube is scaled in proportion. In this case, this happens because the edges of the 2 opposite faces share the edges with all 4 unselected faces, and therefore they all get scaled, rotated, or adjusted as well. That's the logic and reasoning behind this specific adjustment. So try to experiment and understand the logic that defines the cause and effects of other adjustments. You can do that now or as homework, but do it. Learn to edit your shapes. Learn to edit your shapes. It will make a huge difference in you being capable of creating all sorts of awesome complexities in your 3D models in the future. We're almost at the end of this lesson. There's a lot that goes into 3D modeling, so I'm gonna break it up into at least 3 different parts. Before we stop, let's try making a few other shapes. Create a cylinder and a pyramid. Select each one, turn down the corner settings so you have perfect edges on your pyramid and a flat top and bottom to your cylinder. Try experimenting with moving, scaling, and rotating the points, edges, and faces of these shapes and all the rest of the 3D shapes. You'll see the videos sped up of me experimenting doing this now. Try doing this yourself. Try doing single selections to start, then selections of multiple points, edges, and faces, and learn all you can about the different ways you can edit all the different shapes. Don't be afraid of the weird ones like the helix. Finally, let's make a sphere. You'll notice the sphere's default setting is to have 64 sides. Turn both of these side settings down to about 12 and turn on the flat setting in your visibility section so your sphere has flat faces, and try making all the same edits to your sphere as well. This is a perfect opportunity for me to show you one last thing you can do in edit mode. With the faces option highlighted in blue in the top menu, hold shift and click your background somewhere to the top left of your shape and drag down towards your shape. A box will appear, like when you're taking a screenshot. You can use this to select multiple faces, edges, or points at once, based on which ones are inside your box when you release the mouse. For your homework, learn to edit your shapes. This is your Spline mantra. Learn to edit your shapes. See all the different ways you can edit each shape. Faces, edges, and points make up the entirety of the 3D world. These tools and actions are the foundation of your skills and will be the support system for how far you can take this. Get it down, practice, and understand these tools inside and out. We'll continue learning 3D modeling in the next lesson, and it'll be useless if you don't get everything you've learned here perfected first. There's some really fun and exciting tools coming up in the next lesson. I know the ones you learned today aren't the most exciting, but like I said, it's going to be the foundation for the good stuff. Awesome. Do your homework, learn to edit your shapes, and I'll see you guys very soon. This is lesson 1.6, Intro to 3D Modeling, Part 2. Extrude, Inset, Loop Cut, and Edge Slide. Let's start this lesson off exactly like last time. We're going to make a new spline file, add your favorite color to the background, create a perfect cube by holding shift and dragging down, reset the cube's position, make it your other favorite color. Finally, turn down all the corner settings so you have a perfectly proportional cube with sharp right angle edges. Select the Smooth and Edit button again. Turn down the Subdivision modifier to 0. We're going to learn all about this tool today as well and how it's useful in 3D modeling, but that will be a bit later. Set your perspective to isometric at the bottom so you can see 3 sides of your cube, and let's start learning more about this top modeling menu. If you select Extrude to the right of the faces, edges, and points, and select the top face of your cube, you'll notice a new blue circle has appeared on your 3D controls. This is your Extrude tool. Click it and pull up. You'll notice the top face of your cube has been extruded, similarly to when you moved your face upwards in the last section. The difference here is that you'll notice there's 4 new faces that have appeared on your shape. These 4 faces are a new part of your shape which can all be individually controlled. Try doing it again. You'll notice a new section is created or extruded each time. Additionally, you can move, scale, and rotate this face and the extruded faces again from the adjusted sections that you created. For a quick sneak peek of what's coming, try making each section smaller or different like this, and try increasing your subdivision modifier on the right. You'll notice the higher the number goes, the more your shape changes from a blocky geometry to a curved organic one. Now undo this and try pulling extrusions from different directions. Each face can pull a new extrusion, and each new extrusion offers additional faces to play around with. Select 2 faces that face the same direction but don't touch each other. Both faces will extrude together. Now try selecting faces that do touch. You'll see that they extrude in complement with each other. Between each extrusion, you can move, scale, and rotate the faces to adjust them. For a minute, watch what I'm doing on the screen to see all the different ways that you can use this tool. Extruding faces on right angles with each other will form new diagonals and faces in different ways. Adjusting your subdivision will allow you to turn these blocks into organic shapes, but I suggest leaving this step until you're finished with the shape that you're building. Okay, now let's go back to your perfect simple cube. Select Inset this time, to the right of Extrude. This tool insets your faces by creating a smaller face within the selected face that derives from the corners. A 4-sided face will inset from those 4 corners. As you pull up on your blue circle, you'll notice a smaller square forming with 4 outer polygon shapes. This face can be moved, scaled, and rotated as well. If you move it up, you'll see you kind of get a house-looking shape. You can try twisting it then pulling out another inset. Also, you can move and extrude the faces inward as well, and combine the inset and extrude tools together. This tool has a ton of uses. The more experimenting you do with it, the more you realize all that you can do. Now let's practice how we can use these tools together. Extrude your cube into 3 sections. Now select the top and bottom faces on one side and try insetting them. Use the arrow to pull out your insets. Go back to extrude and pull an extrusion again. See how they work together to make new things possible? Now let me show you how to create symmetry in your 3D models. With this 3-section shape, select opposite shapes. With your extrusion tool selected, your extrusion circle will appear up top, but you'll notice when you pull it, it will pull the 2 selected faces out in the direction they face. Their sizes will be exactly the same. This is true for all your different tools, and it's how you make perfectly equal, symmetrical edits to your shapes. The same is true for the inset tool. Watch how I make symmetrical insets by selecting equal but opposite parts and holding Shift. Increasing the subdivision turned it into an organic and curved shape, like deer antlers. But you can always go back to edit mode and your geometry will still be there. All right, let's go back to a cube again. The third tool is the loop cut tool. Select it, and you'll notice when you hover over your cube, a red line will appear in the center of each face. If you click it, it cuts a loop around your shape, dividing those faces and creating a new edge. After you click to make a loop cut, all of those edges will remain selected. In this case, there are 4. As you can see, you can scale and rotate the 4 selected edges together. You can even slide the loop cut back and forth to change its location. Loop cuts are always made available in the exact center of a face or shape. As you can see, if you make one loop cut, the next red line will appear in the middle of that cut and the next edge. Loop cuts are the way you create new faces, edges, and points on your shape without changing its form. You can make unlimited loop cuts and add complexity to a shape. If you can't seem to add a new loop cut between 2 previous ones, try zooming in or moving your mouse up and down the area you wish to cut. The fourth and final tool is the edge slider. The edge slider moves edges back and forth along the face where it is located. Just like the other tools, you can adjust a single edge or multiple edges at once. If all 4 edges in a loop are selected, it will slide them evenly back and forth. If only 1 or 2 edges are selected, they will slide back and forth as well, but they will become diagonal because they are anchored at the points where they meet the other edges, which remain anchored and unchanged. As you can see, if I select this one edge, only it will slide. If I select the edge perpendicular to it, they both slide together, but the opposite edges remain still, causing the lines to slant. If I select opposite edges, all edges will move because while only 2 edges are selected, all 4 points are selected. Technically, all 4 edges. Finally, there's one last tool which disappears and reappears, and it's called Dissolve. It will only appear on the menu when edges or points are selected. Dissolve deletes or eliminates selected points or edges. It will allow you to turn a divided face or shape back to its more simple form. Be careful when using it because it can create irregular geometry. As a rule of thumb, if you're removing edges and points, try to remove the associated counterparts of those edges and points. For example, when dissolving an edge in a loop cut, make sure you dissolve its related edges that are part of that same loop cut. On a cube, it's 4. All right, that's going to be it for today. These tools are so versatile and you can do so much more with them than what I've showed you here. You know the essentials of how they function. We've come to another point in this guide where I'm confident that you experimenting with these tools and practicing on your own is going to be way more productive in you learning than watching me mess around. So do it. Who knows what I'm going to say next? I'll give you one guess. Say it with me. Ready? 3, 2, 1. Learn to edit your shapes. Brilliant. 10 points for Gryffindor. Next time, we're going to finish off with the final part of 3D modeling, which will include advanced modeling settings, sculpting tools, other random techniques, and some tricks and tips. This is lesson 1.7, Intro to 3D Modeling Part 3, Sculpting and Subdivision Modifiers. Today's the third part of the 3D modeling lessons. 3D modeling is a very important part of your creative tool belt, but I'm sure we're all looking forward to moving on to new parts of this program. Today we'll be learning all about sculpting, completing your understanding of subdivision, and learning the last bit of settings that affect all your 3D tools. As you know, Spline is my favorite 3D program, not only for its current state, but because I believe strongly in its team and its future. Although I expect improvements to this part of the program, I try to give my honest opinions to you guys always. That's why I'm obliged to say, if 3D sculpting is your main interest and not just a piece of your 3D toolkit, there are other 3D sculpting softwares that are just undeniably better tools. I'd recommend free tools like Sculptress and ZBrush especially. There are even many tools for the iPad that allow you to use your Apple Pencil for greater control. That being said, Spline has a blossoming sculpting feature that is certain to receive more love in the future. For now, there are 4 specific tools. Sculpting tools can be used on everything, but their effects look best on rounded or organic shapes like spheres or geometry with the subdivision modifiers turned up. You basically already have a full understanding of the subdivision modifier. Think of it like this. Turned down to 0, you have a Lego brick. Turned up to max, you have Play-Doh. Sculpting tools will look best when you use it on the Play-Doh. For now, let's start this lesson by making a perfect sphere in a new Spline file. Add some color to it for some fun, reset the position, and click Smooth and Edit, and then turn up your subdivision modifier. You're going to access your sculpting tool menu by clicking the paintbrush in the top 3D modeling menu. You'll notice a new double circle has appeared when hovering over your sphere. These circles represent the radius and strength of your tools. These circles wrap around your shape as you move around to different edges. Editing or sculpting from the front allows for longer adjustments, while angled edits from the side can be more easy to see their effects. A new set of settings called radius and strength have appeared in your right menu. The radius and strength of the sculpt brush can be adjusted from this menu. These settings affect all 4 of your sculpting tools. As you can imagine, radius adjusts the size of the area that you'll be controlling or editing, and strength controls the effectiveness or amount of change each tool has within the selected radius. Grab is your first tool on the left. As you move around your sphere, you'll notice the angle of your circle adjusts to align with the direction of the face that it's covering. The grab tool allows you to grab that precise area of your shape. When you click and hold, you'll see that you can pull out, push in, and otherwise move around that selected part which you are grabbing. Unlike other sculpting tools in Spline, grab continually selects, connects, and adjusts with a specific point, as opposed to moving along the surface of your shape. When you're done making your adjustment, release or sometimes double-click the mouse to release your grab. Next, we have the draw tool. The draw tool adds mass to the surface of the shape as you move about. You can change the radius and strength of your tool to thicken and increase the overall impact of the mass that you're adding or drawing onto the surface. If you hold control while using this tool, it does the opposite and erases or removes mass from the shape. Third, we have the draw clay tool. This tool is essentially the same as the draw tool, except it adjusts the surrounding area outside of the area you're drawing to be more smoothed out or aligned with the rest of your shape. Think of it as a broader version of the draw tool that has a less defined action, or one that keeps more consistency with the rest of your shape. Holding control will also make this tool's action reverse. Finally, you have the smooth tool. This tool smooths out the surface of your shape. It's a way to add consistency to the curves and adjustments made by other tools on a micro or macro level. With all of your sculpting tools, you can zoom in and out as much as you like on your shape for smaller and larger edits. The spline sculpting has some bugs that need to be worked out in its current state. You'll notice sometimes they fail to work, or you'll need to double click to end your edits. Sometimes for making organic shapes, it can be easier to just make them in flat geometry in a way that the subdivision modifier will take care of the smoothing for you. Watch me make a quick cartoon hand using this technique. Also, just so you know, sometimes I prefer to use just Ctrl-Z or undo instead of the smooth tool, and undoing can often be a lot better than using some of these sculpting tools. Finally, there are just a few more settings which apply to your modeling tools from lesson 1.6 that we should cover. Make a perfect cube for this, flatten out the corners, and click Smooth and Edit. Now select two adjacent or perpendicular faces on your cube and open this setting box next to your paintbrush. Under Extrude and Inset, with the mode selected as Group, try extruding these faces. The faces will extrude in complement with each other and remain touching on their diagonal. If you change the setting to Individual, both faces will extrude in their individual directions. In this case, up and sideways. The same is true for Inset. When set to Group, there will be no inset face created where the two faces touch on the edge. If set to Individual, they will each inset on their own face individually. The next is Extrude Direction. If set to Normal, they will extrude with their outside faces remaining parallel to the rest of the cube. If set to Drag, those outer faces will become diagonal and drag in the direction of the extrusion. Underneath this, we have our selection tools. To better understand this tool, we're going to loop cut your cube 3 times on all 3 vertices, like shown here. 1, 2, 3. 1, 2, 3. 1, 2, 3. Almost like a Rubik's Cube, but with 4 squares instead of 3. Set your selection settings to box and front. Now reset your camera so only one face of your cube is visible. Click and drag a box to select the 4 center squares on this face. This is how you select multiple faces at once. If you rotate your cube, you'll see only these 4 faces are selected. Now reset your camera again and change the front setting to both and repeat this process. If you rotate your cube again, you'll notice the opposite faces on the other side of your cube are selected as well. This is what the both option does. Now try selecting all 8 middle faces. Now all 8 faces will be selected in a ring around your cube. This is because the selected faces are adjacent to the side faces and your group setting is selected. Now try selecting Paint. Instead of dragging a box, now you can click on a single face and drag your mouse around the faces that you want to select, kind of like a paintbrush. As you can imagine, the front and both settings work the same way with this paint selection style. We're almost done here. Delete your cube and make a perfect sphere. Change its sides from 64 to 12 each. Set its visibility to flat so you can see these faces, and hit Smooth and Edit. Turn the Subdivision modifier down to 0, and set your selection settings to Front and Paint. Now, select your face option on the far left and select a group of faces on your sphere. Hit Delete to remove them and create a hole in your sphere. Next, select Edge to the right of the face option and select a single edge on the outside of your hole. A new tool has appeared called Fill Hole, which, similar to Dissolve, is only visible when it can be used. Click it. You'll notice it filled your hole with new geometry, but it's rather flat and unlike the surrounding sphere. Ctrl-Z to undo that. Go back to your settings and at the bottom change Flat to Curved. and try hitting fill hole again. You'll notice this is a little better and more rounded, but still not quite right. Finally, you have the N-gon option. Hit Ctrl Z and try this one out. This option fills the entire hole with a single face. Brother, ew. These are the ways you can refill your holes that you've made in your geometry. Honestly though, Ctrl Z is the best tool in 75% of these situations. And generally, you should just undo and go back. All right, now you know. For your homework, you should practice creating a unique shape from a cube using your extrude and inset tools that we learned about, and loop cut as well. Then turn up your subdivision modifier to change it into a more organic shape, and try messing around with your sculpting tools on this shape that you've created. In fact, try experimenting with this whole top 3D modeling menu and get familiar with it. Get as comfortable as you can with sculpting and the unfortunate bugs that it has in it. Learn to edit your shapes, learn to edit your shapes, learn to edit your shapes. I think we're gonna need an acronym for this at this point, so LTEYS. LTEYS.
Hey Spline gang, Connor here with the Motion Visual. Welcome back to Spline the Complete Guide. This is lesson 1.8, Intro to 3D Modeling, Part 4, Booleans and Geometry Merging. Booleans are a way that you can merge or combine shapes, subtract or remove them from one another, or intersect or combine their overlapping or shared areas. You're probably confused about this, so let's just learn by doing. Like always, make a new Spline file, add a fun background color, and make a cube, give it another fun color, reset its position, but don't worry about the corners this time. Now, make a perfect cylinder that's skinny enough to fit inside the cube, and then scale its length to be longer than the cube itself on both sides. Rotate it sideways 90 degrees. If you remember, holding shift while rotating will allow you to move it in perfect intervals of 5. Shift and select both objects at once. Incidentally, we're going to learn a new important tool right now. Alignment has appeared in your right menu. Select the X, Y, and Z drop-down menus and select the center option from each one. This is how you can perfectly align and center shapes with one another. You'll see that your shapes are now centered with each other. Just quickly to complete learning about this alignment menu, the min and max options will align your shapes to the far ends of each side of each dimension. The distribute options will evenly distribute multiple objects along their respective dimensions. With both your objects selected, check out the Boolean menu just above the alignment one. There are 3 tools. The first one, subtract, removes the overlapping parts from the base object. The base object is always the bottom layer on your left list, and the top layer is subtracted from it. Try clicking subtract. You'll see that your cylinder has been subtracted from your cube. Ctrl Z to undo it, and now try moving your cube above your cylinder in the left menu list and hitting subtract. This time, it's your cube that's been subtracted from your cylinder. Since the cylinder was larger, it's been divided into 2 parts, and the empty spot is where your cube was. Before we move on, undo this and move your cylinder to the top again on the list. Select both shapes and hit subtract. In your left menu, you'll see that the Boolean you've created is actually a group, and your shapes are technically still individually separated. Click on your cylinder in the left menu. Now try using your controls. You'll notice you're still able to move, rotate, and scale that shape on its own, although you can't see it. Watch me try a few different actions. In addition, you can still adjust the settings of your cylinder. I can adjust its sides like this, or even the hollow settings, to add a negative hollow part of the cylinder to this Boolean inside the cube. Finally, there's one more thing you can do, and this applies to all 3 of your Boolean options. With your cube and cylinder subtract Boolean remaining, try making a new sphere. Move this sphere so that it's overlapping with your cube, and then try moving it into the group of the Boolean. You'll notice that now your sphere is also subtracted from your cube. Okay, now go back to your cylinder and cube aligned in the center without any Boolean added to them. The next Boolean tool is intersect. Intersect simply creates an object from the parts where both selected objects overlap. Select your cylinder and your cube, and try clicking the intersect or center tool in your Boolean menu. You'll see the shape that's remaining or created is the area where both the cube and cylinder overlap. This is how intersect works. Go back again to your 2 shapes and try the 3rd option in your Boolean menu called union. Union combines the selected objects into a single one. To make a Boolean a permanent single shape, you'll need to select it and hit apply and edit under the Boolean modifier setting menu. The final tool in the Boolean options menu is the merge geometry option, which, as far as I know, is the same as the union option tool, except it skips the part where the two objects remain individual. You can use Booleans to make all sorts of fun things. Check out this box outline I can make with a square and a rectangle. Make a cube, and make a Boolean like the cylinder one we made, except use a rectangle this time. After the subtraction Boolean is made, duplicate the long rectangle once and rotate it 90 degrees. Then duplicate it again and rotate it 90 degrees in the third dimension. Select all three of them and scale them up to get your desired effect. You'll have a cool outline of a cube. Alright, that's it for lesson 1.8. 3D modeling is done and we're learning about materials next time. You guys know what your homework is. Practice with all the different Boolean options and see all the different things you can do. And learn to edit your gosh darn shapes. Y'all understand? Learn to edit those shapes. LTEYS. This is lesson 1.9. Intro to Materials Part 1. Lighting, color, image, and blend modes. Start this lesson with a new file, leave the background gray this time, make a sphere about 300 in dimension, reset its position, and set its color to a medium light blue. We already know a little bit about the first two materials, lighting and color, but let's learn a little bit more today. Light is what makes the capital D dimensions in 3D exist. It is the most important material. As you know, every new Spline file starts off with two things: a useless flat gray square, and a brilliant, wonderful, righteous, all-important directional light. On the first day, God said, well, that's a tale from a different guide, I suppose, and we don't really have time for Genesis today, but let there be light. Click your directional light, which is that square atop the diagonal line, and set its blur to 2.5 for today. Our first material is lighting. Lighting as objects are not to be confused with lighting as a material. Lighting the material defines how the light objects, like your directional light, affect each shape. Lighting will always remain in the material stack. The lighting material controls how light affects the object, adding highlights, shadows, and giving a realistic sense of depth. Any painter will tell you that images are all about lighting. Within lighting, there are 4 distinct categories which allow you to turn the light's effect on your shape or object into realistic, smooth, gradient transitions of shade and hue, or cartoonish, 2D, abrupt, defined changes in values. You can use lightings to make objects shiny, metallic, matte, soft, reflective, colorful, and so much more. Light affects each and every material in a different way, but for now, we're just going to learn the 4 settings that affect your color. The 4 categories of lighting are: number 1, Fong. This is the default light setting. Fong is a reflective setting. Its color is set as a dark gray by default, but this value can be changed in grayscale to adjust the shadows and highlights of your shape, or in color to make the lighting seem to shine in different hues on your object. Shininess can even be increased to add or subtract reflection of the light. Number 2 is Lambert. This is the counterpart to Fong and is a matte setting. It is set to complete black by default, and you'll see that when this color is changed, it has a much more drastic effect on your object's reaction to the light. Number 3 is Tune. This is the cartoon lighting effect and allows you to create those abrupt color changes I mentioned. It's great for creating 2D in 3D effects on your designs. Finally, number 4, Physical, is the most complex lighting category and offers the most options for realism. It allows you to change roughness, metallicity, which I checked is actually a word, and reflection for different unique effects. Watch as I mess around with them really fast to show you all the different things you can do. Physical lighting can even be combined with image layers to create bump and rough maps, which use the data from the image to mimic the way that light would appear on what's pictured in that image. We'll learn more about that towards the end of this lesson. Number 2 is color. Color applies a solid color to the object, giving it a base color without any texture or lighting effects. These colors can be adjusted in tone and opacity as well. As you can see, if I move color above lighting in the material stack, it takes dominance over the lighting layer and eliminates the shadows and highlights that give your sphere a 3D look. You can also achieve this by turning your lighting opacity down. Color seems like a very simple material, and it is in many ways, but this simplicity is actually what gives the color material so much functionality and utility. It is obviously used to add solid color to 3D objects, but similarly to light, it is an incredibly useful way to define specific objects in their relation to others and to your scene as a whole.
Material stacking or combinations are where the real magic happens in Spline, and color is almost always a significant and important part of these material stacks. Color is a wonderful way to add nuance to all other materials in positions both above and below them in your material stacks. Number 3 is the image material. This is where we start adding new materials to our objects. To create a new material layer, select your object, go to the material panel in the right sidebar, and click the plus button up top to add a new layer. Then you can choose your material type from the drop-down menu. As noted, they can be moved up and down the list by clicking and dragging them. As a rule of thumb, the top material will block out all other materials below them unless their opacity is turned down or their blending modes are adjusted. Some materials break this rule. For example, lighting allows color and other materials to shine through, but it generally applies to all other materials. This number here is the material's opacity. It can be turned up and down or switched all the way off and on by clicking this eyeball. Image material layers let you apply an image as the surface of your 3D objects and is incredibly useful for adding detailed designs or patterns to your shapes. Images can be used in so many ways as you can imagine and are only limited by what appears in them. Image layers are also a fantastic shortcut or workaround in attempting to create whatever they depict by using all the rest of the material layers. Spline comes with a few default images. If you create an image layer and then select this map here, your sphere becomes a perfect globe. All the settings in this material layer can change a wide variety of properties. You can change the scale, positioning, angles, and so much more to achieve your desired result. There are even different layout styles or projections up top, which can be applied and are designed to work well with different types of shapes. The best way to learn about these image settings is by experimenting with them on your own using all different types of shapes. Test out the differences when applied to a sphere versus a cube, versus something like a dodecahedron. That'll be the first part of your homework. To use your own images, you can click this upload button here to access them. Try using all different types of images from patterns and surfaces to landscapes and even selfies to see what kind of different things you can create. Each material layer in Spline offers creative ways to modify and customize your 3D objects. Experimenting with these layers can really enhance the visual style of your scene. We'll continue learning about the rest of the layers in the next few lessons of this guide, but before we finish up today, we have to go back and cover two things I glossed over: lighting maps and blending modes. Stack your materials in order with lighting at the top, image in the middle, and color at the bottom. Set your image layer to this cobblestone image to the right of the map, go back to lighting, and set it to physical. You'll see a new setting called Bump Map has appeared at the bottom of the physical lighting category. This setting will allow you to use your lighting and image materials in combination to achieve an awesome 3D effect. If you set the bump map from none to image 12, which is your cobblestone image, and turn the intensity down to a negative setting, you will see that the lighting has changed to make the cobblestones appear to become affected by the light in such a way that their dimension comes to life. You'll notice that the edges of your sphere are still smooth, because this doesn't actually change the physical surface of your shape despite appearing to do so. This is just another way that image layers can be used as a shortcut for creating realistic looks without the tedious work of 3D modeling or advanced material combinations. Try this bump map effect with your own images. This is the basics of how lighting maps work. Now, for blending modes. Set your lighting back to Phong. If you click the double circle to the left of the eyeball, you'll notice you can access 4 blending modes in Spline. We'll learn about them by seeing how they affect your image layer's relationship to the blue color beneath it. Number 1 is normal. Normal just places one layer over another. You'll only see the top layer covering what's below it. No blending unless the opacity is adjusted. Number 2 is multiply. Multiply darkens the layers by multiplying the colors. The top layer mixes or multiplies with the next layer or layers, making everything darker. Number 3 is screen. Screen is the opposite of multiply. It lightens by screening the top layer onto the next, sort of like projecting a light through it. It blends them in a way that makes everything lighter. Finally, number 4 is overlay. Overlay combines the effects of multiply and screen, depending on the values. Dark parts get darker, light parts get lighter, and it adds contrast, giving a more intense look, and can be used to make your shapes pop a little more. That's it for today, but before we go,
Here's a favorite project of mine which utilizes color, lighting, and image layers to achieve a really cool result. It's a holographic Pokemon card I made with images of the card and a separate section that's the image of the Pokemon illustration, which reflects the light much more strongly and uses bits of color to add realism. It's not just materials, but material stacking that makes this possible. The card is animated to move back and forth, as well as other lights of different colors in the scene, and that's what adds this green and blue holographic effect to this card. This is a great way to use light, color, and images together. That's it for lesson 1.9. We'll be moving on to the next 4 or 5 materials next lesson. You guys know your homework, learn to edit your shapes, and now your materials.
This is lesson 1.10, Introduction to Materials Part 2, Video, Depth, Normal, Gradient, and Noise. All right, let's go. For this lesson, I'm going to continue to explain and describe 5 new materials, showing their use on a simple sphere like last time. Practice on other shapes when we're done. I'll also share some of my favorite uses of these materials in my own work and help demonstrate their full range of possibilities and what you'll be able to do in the future. Start this lesson with a new file, leave the background gray, make a sphere with the dimensions about 300, reset its position, set its color to something fun and medium in tone. Material number 4 is video. Hit the plus sign to add a new material and select video. Video material layers work exactly like image layers, except they let you add videos instead of images to your objects. You can upload your own videos the same way you do with images and adjust them in all the same ways. The video material is currently only available for paid users, but it's super cool and totally worth it if you can spare the $10 a month. There are other pro features that are included as well. For some reason, Spline's default video for testing video materials is this weird cat licking itself. As you can see, videos don't look too great on spheres unless they're edited to specifically fit the curvature, so they're best used on flat shapes and objects. Here's a few examples of other Spline users using video layers in their projects, since I'm too cheap for it. I'll tag them so you can find them in the Spline community. By the way, there's a Patreon link if you think I deserve a pro subscription, just saying. I make tons of animations on Spline, but I've never really used this video layer for anything. It's a fairly new feature, so I could barely find any projects using it, but here's a cool one from Tanya DeZone using them on some iPhone mockups. You can find her in the Spline community. And here's another example from a Spline tutorial on a handheld Nintendo. You're still early, so you could be the first one to really make something awesome with this feature. For number 5, we're going to cover depth and gradient material layers together, as they're quite similar. These materials add a gradient based on your objects, useful for creating smooth or sharp color changes and transitions, faking lighting, creating distance, or emphasizing perspective in your Spline builds. They essentially create shifting hues, values, tones, or colors on your shapes, as opposed to the color material, which is one specific setting. Depth is essentially just a 3D version of the gradient material. So choose depth for your 3D objects and gradient for your flat or 2D ones. The 2 origin settings are vector, which lets you place your gradient in relation to their defined point in space, or camera, which adjusts it to the camera's location and angle. The linear and smooth options adjust the smoothness of the color and value transitions. You can change the colors in your gradients by clicking on these ovals and choosing just like in a color material. You can even move these around and add new ones by clicking on a new point along this line. The opacities can be changed individually as well. You can add as many different colors as you want and overlap them or move them around past each other. Gradient and depth each have 2 main styles. The first is linear, which changes color across a line with points in different colors or settings and also locations. The second is radial. This style emits from a center point in all directions, changing at spots in different circumferences. Think of it like the Earth, which has a core and a crust, and how they change based on their distance from the center. The location of your depth and gradient materials can be set based on the location of your objects or the material's location in the scene. This allows you to create gradients which accurately align across space and different objects. Change this by adjusting position from local to world. Origin moves the location around on your 3 axes like so, and near and far essentially sets the sizes or distances of your gradients. I love to make simple visuals and mood lighting videos for folks to put on their screens and projectors to provide a certain vibe. I put them all on YouTube. Gradients are a wonderful way to do this, providing motion and color without complexity. Here's some radial ones I made, and even a 3-hour digital sunset using gradients. See my visuals playlist for more of these. Some have music and others are silent, and they're great for studying, meditation, chilling, or party lights. Material number 6 is normal. The normal material derives from a 3D concept called a normal map, which is a traditional way to use color to designate or define angles and directions on a 3D model. Normal maps are green at the top, blue moving towards the left, purple towards the bottom, and as you continue moving counterclockwise, pink, and finally yellow. Each angle or degree you can see on the front occupies a combination of these hues and colors. You'll notice as you rotate your sphere, the colors remain in their respective angles. Normal maps are an awesome 3D tool that have been around for a while and have become even more useful with AI. They help adding light effects and textures on 2D images, as well as assisting in converting them to 3D. The colors of a normal material can be adjusted by turning off and on the axis related to the directions of each color. I use normal material layers all the time just for the fun colors, and especially on shapes that have multiple angles. I love the spectrum look it provides to weird shaped objects like this gobstopper animation I made. You'll notice that the respective colors stay on their associated edges always, which makes for a fun gradient and spectral shift in your animations and movements. This psychedelic rainbow mandala is another project I made that's all colored with normal materials. All the different angles of the shapes each reveal a new color in the spectrum. It's so simple and so fun. Definitely mess around using normal maps on shapes with lots of different angles like this. Finally, material number 7 is noise. The noise material is another layer which has so many different uses and possibilities that will definitely require its own lesson or 3. Noise is an essential concept in 3D design used to add texture, detail, and randomness to surfaces or landscapes. Technically, it's a mathematical pattern that appears random but has controllable characteristics, making it extremely useful for creating realistic materials and effects. There are many different kinds of noise which can be colored, scaled, smoothed, and arranged in millions of different ways. It's a fantastic way to create anti-patterns in your material stacks. Fantastic for texture and realism. I'm not nerdy enough to know, but I asked ChatGPT what all the different types of noise equations actually are, and you can pause right now if you care to learn about them. I didn't, but you might. In the noise material settings, size and scale lets you adjust the size of the patterns based on the individual directions or axes or all together at once. Movement moves the location of the pattern around on your shapes. Each noise type has between 2 and 4 colors which you can include in them. The opacity of each color can be turned up, down, and off to let underlying materials shine through. Distortion introduces warping or twisting to the noise patterns, making it less uniform and more dynamic, and the factor options determine the intensity of the effect. Finally, Voronoi noise, the last type, has its own secondary category of 8 styles which are all unique in themselves. This style of noise has its own unique settings. Smoothness adjusts the transition between the 2 colors, or the high and low cut, which are essentially cells and barriers created by the 2 colors in the noise. Voronoi could almost be a unique material in itself. Definitely try messing around with all the different styles in this specific noise setting and see all the different things you can do with them. This is an animation project I made using noise in a few ways. The curly S-shaped thing moving up and down on the left is made with a Voronoi noise, and it's animated to change different colors as it moves. The glass disc in front of it really adds a cool addition to this noise pattern by refracting it in fun ways. We'll learn glass very soon, so don't worry. Also, the frosted glass white bubble thing on the right gets its static frosted effect from a noise material as well. One which is much more subdued, scaled down much smaller, and totally without color. You can see the variety of noise options in just these two objects. This example even combines noise and depth gradients together. Alright, that's it for lesson 1.10. We got 4 or 5 new materials coming at you next lesson. You guys know your homework. Learn to edit your shapes and your materials. Actually, just forget the shapes for now. Materials are enough of a handful. Test your materials on different shapes and mess around with all the settings. Try using the blending modes we learned last time on all your materials and move them all around in different positions in the stack, changing blending, opacity, and combinations in as many different ways as you can. There's a lot we've covered in these past 2 lessons, so don't be fooled with how short they've been. There's only so much I can teach you. The real learning comes from you experimenting with your new knowledge as much as you possibly can. And of course, combining it with everything we've already learned. Don't skip this stuff. We've got future doctors in college right now cheating with ChatGPT. Do you want them performing your future surgeries? I didn't think so. So, learn to edit your materials, knuckleheads. Fresnel, Rainbow, Tune, and Outline are coming at you next time. This is lesson 1.11. Intro to 3D Materials Part 3, Fresnel, Rainbow, Tune, and Outline. I'm going to continue to explain each material, preview their effects on a sphere, and show you guys some of my favorite uses of them in my own work and the work of others to show you what's possible. Start this lesson with a new file, leave the background gray, make a sphere with the dimensions about 300, reset its position, and set its color to something medium in tone and fun. Hit plus to add a new material and put it between light and color in your material stack. Material number 8 is Fresnel. The Fresnel layer simulates how we perceive reflections on surfaces depending on the angle of the light. The Fresnel layer shows a color that fades away as it gets closer to being parallel with the angle of the camera, or your eye, or perspective. This effect is handy to reproduce shiny or metallic surfaces. It adds a highlight around the edges of an object based on the viewing angle, which can create a subtle glow or reflective look. It can also be changed to any color or even used with darker colors or blacks to add shadows and color effects instead of glows. Similarly to the normal material, Fresnel materials remain on the edges of a shape no matter what direction your perspective is or what rotation the shape is. The 4 Fresnel settings, bias, intensity, scale, and factor, can be a bit tough to get used to. When first experimenting, they seem to all act quite similarly. And honestly, they kind of do. I can tell there are some differences, like intensity makes the edges more dense, and bias moves the outline inward more so than the others tend to. But after experimenting, each setting seems to be very similar, even to me. Fresnel is a great and effective tool, but if you want to get the technical and accurate info about the settings, I'm afraid it's time for Jeopardy music, a ChatGPT answer, and a pink screen that you can pause to inform yourself. If you choose to do that, maybe you could teach me about what each setting does. For simplicity's sake, just know Fresnel adds gradients, edges of glow, color, or shadow to your object's outer edges. Experimenting with its settings on different shapes may reveal the nuance of each of the different settings. This is a quick animation I made to show how multiple Fresnels can be used together. Here, a purple Fresnel is set to the outer edge, blue in the middle, and green towards the center. I've shown the material stack at the bottom. Even when the objects move around, the outer purple Fresnel remains on the edges of all the shapes. Material number 9 is Rainbow. The Rainbow material gives objects anything from a 2 monotone hue shift, like that car paint that changes from purple to green based on which direction you're looking from, or a crazy stack of intensely changing rainbow gradients depending on its settings. It can add a metallic look like bismuth crystals, or an iridescent look like bubbles or gasoline in puddles. It uses a combination of RGB settings to control its results, along with frequency and movement to determine how often this iridescence changes, etc. It can be extremely versatile when paralleled and blended with other materials like noise or displace, or on shapes with lots of different angles. The RGB settings control how much of each color is included in the rainbow. Red produces more red and warm tones, green will make more greens and mid-tones, and blue will make more blues and cool tones. These settings can be positive or negative. Frequency controls how often these hues shift, and movement moves them around on your objects. Like I mentioned, frequency determines how frequent these shifts occur in relation to your shape. Rainbow even has its own noise and noise scale setting to add nuance and shifts in shape to your design. Very large scale settings are great for making these gasoline and bubble looks that I mentioned. The offset options let you change the rotation of the direction of the pattern, as well as which way the movement will travel when adjusted. There is so much you can do with the rainbow material by messing around with the frequency, RGB, and noise settings. So dig in on this material for a while to see all that's possible. This is an animation of 3 different shapes with rainbow as a dominant material in the material stack. Each shape is animated to rotate, and many of the materials, including rainbow, are animated as well by changing the settings in each state. You can see how animating frequency, movement, noise, RGB, etc. creates different looks even with the exact same stack of materials, which are shown beneath them. These are 12 metallic materials featuring rainbow that I made, which you can open and use by following me in the Spline community at Motion Visual. I've got tons of other projects you can access there for free as well. Material number 10 is Toon. Toon adds a cartoon-like shading, simplifying shadows and highlights for a flat, illustrated look. It's used to create a stylized, cartoon-like shading effect on your 3D objects. It simplifies the way the light and shadows appear, producing distinct, flat areas of color, tone, and shadow instead of smooth gradients, making your objects look more like they belong in an animated cartoon or a comic book. Toon, like rainbow, also has a scalable noise feature for graininess in transitions. The settings necessary to get a proper look in this material can be difficult and require some practice. My best tips are getting your ovals directly up against one another for sharper transitions. If you increase the blur setting on your directional light or other light objects, this will be effective in getting a better 2D toon effect. This material is an awesome way to create images and scenes that appear 2D even though they're 3D, no matter what angle you're viewing them at, and especially when combined with our next material, which is material number 11. Outline creates a solid defined outline around the object, giving it a 2D cartoon defined edge effect. And like I said, it's very effective in combination with the Toon material in creating 2D or drawn cartoon looks in objects, no matter what angle you view them from. This can be perfect for creating comic illustrations where you can just adjust the angle of your viewpoint instead of redrawing scenes over and over. Like the Fresnel layer, outline will always stay on the outer perimeter of your object at every perspective. Outlines can be adjusted in width, threshold, and smoothness, or the transition or sharpness of the outline layer. While often used in black, the outline can be set to any color or tone or white or anything else that you'd like. Outline is to Fresnel what color is to depth or gradient materials. Outline can be another tricky one with its settings. The width setting sets the width of the outline of your shape, but this setting is relative and changes based on the closeness or the perspective to your object as seen here. The both and inside setting moves your outline to the inner or outer edge of your shape. Threshold changes the amount or parts of your object covered with the outline, and smoothness is meant to smooth or create a gradient between the edge and the rest of your shape, but it generally just ends up making the rest of your shape darker instead. The continuous setting underneath is lesser used. It's there to add additional lines to the faces of your objects and create hatch mark style shading that you might see in some pen and ink illustrations. These two projects by Spline community user Levi Magoni use the tune and outline materials to create that 2D and 3D effect. This robot from a Spline tutorial shows the outline effect looks like a drawing no matter which angle you view it from. Here's another awesome Spline piece by Spline user Add Soul that I modified and animated a little. It uses those continuous line shadings from the outline material as well as patterns, which we'll learn about in the next lesson or the one after. Alright, that's it for lesson 1.11. This is lesson 1.12. Introduction to 3D Materials Part 4, Glass and Matte Caps. I'm going to continue to explain each material and preview the effects on a sphere and show you guys some of my favorite uses of them in my own work and the work of others to show you what's possible. We're going to start this lesson with a new file, leave the background gray, and make a perfect sphere by holding Shift and make its dimensions about 300. Reset its position to center it, hit plus to add a new material, and put it between light and color in your material stack. Change the middle material to glass and leave the color gray for now. We see what appears to be a gray sphere. If we click the eyeball to remove the lighting material effect, the sphere seems to fully disappear. Let's learn why. Material number 12 is glass. The glass material is one of my favorite materials to play with in Spline. It's perfect for creating transparent objects like windows, liquids, plastics, frosted glass, and so much more. My favorite way to use this recently, and one I've been experimenting with a lot, is creating crystals and faceted gemstones. When combined with other materials like colors or Fresnels and adjusting opacities and blend modes, there is so much possible with glass. The three settings in glass all work hand in hand to create wonderfully diverse effects. Blur obviously changes the blurriness of the transparency of your glass. Thickness adjusts the thickness or simulated density of the glass object. And refraction works in communion with thickness and blur to change the way the light is bent or refracted by the object with the glass material. One way to think of these settings is to remember the simple grade school science experiment of the straw in the glass of water. The water and glass both make the straw appear to both bend and change directions as it enters the glass and the water. While we know the straw remains straight, our eyes tell us that it is bent. This is from the refraction that is being created and bending the light. Pink Floyd's famous logo of white light and the prism creating a rainbow is another example of this occurring in a different way. White light is made of the full visible spectrum of colors, and a prism can separate the colors from the white light because they all bend on different wavelengths. Different notes in music and sound waves work in a very similar way. Next, let's create an icosahedron in our 3D space about 250 cubed in dimension. This is going to help us see exactly what's going on with our glass sphere. Round the corners a bit on your icosahedron. I can't believe I keep having to say that silly word. And change its color material to a normal one so it's got some different colors and tones going on. Reset its position as well so it's perfectly aligned with the sphere. Click the red dot on your perspective menu on the bottom for a side view and move the Z setting on the ico, the new nickname for this shape, to about -400. You'll see it start to emerge and come out from within the glass sphere. Make sure it's fully separated and behind the sphere a little bit, and then hit reset in the perspective menu to go to the front view again. Now select your sphere and turn the blur down to about 4 to get a slightly clearer view of the ico behind the sphere. Now you can see the glass effect. Try moving your sphere from side to side or up and down, and you'll notice the ico gets refracted in different ways by the sphere, and its colors even bend around the outer rim of the sphere itself. Now center your sphere again and try playing around with the thickness and refraction settings. You'll get all sorts of different results based on the different combinations. Thickness and refraction can be set to negative numbers as well, which will flip the shapes behind them and reverse their refractions. As refraction settings get closer to 0, the shapes behind the glass will get smaller and smaller, and then flip and start to grow again as you get deeper into the negative numbers. Thickness and refraction are partners that can team up to do all sorts of cool things. Now try changing your color material to your favorite color and lower the opacity of your glass. You can start to create glass in different colors this way. This can be done with different results by changing the blending modes as well. By combining noise with glass, you can create frosted, sandblasted, or warped glass like you might see used for privacy in buildings or in bathrooms. Here's a few examples of my favorite uses of glass materials in my own work. I use glass refraction, color, and faceted gemstone shapes I've 3D modeled to create diamonds, sapphires, and other fine gemstones and create animations of fine jewelry. The glass refraction, flat facets, and colorful matte caps, which we're moving on to in just a moment, combine to create a beautiful and brilliant gemstone. I'll make a few of these files and animations available for free in my Spline community files for you guys to analyze and experiment with to see how they work. For your homework, experiment with using glass in different shapes and seeing all the different ways you can combine them with other materials. Test the way they affect objects behind them and how they bend the light. Also try combining glass with physical light settings and seeing how those settings affect the look and realism of your glass objects. One last thing to note before we move on. If you're creating a project with glass features as a main focus, try changing the settings in the export menu. Go to export, go to play settings, scroll down to materials, and set your glass precision to high. This will make your file larger in size, but it will make glass objects much more crisp and realistic. Material number 13 are matte caps. Matte caps are essentially pre-built or in some ways faked materials that allow you to add realistic materials of all kinds to your objects with single images. Matte caps can be thought of like a combination of image and normal materials. Like image materials, they use JPEGs or PNGs that are applied to the surface of your shapes. And like the normal material, these features will remain on the same angle or section of your object no matter how you change your perspective or rotate that object. Matte cap images are square photos with circles that appear to be 3D spheres. The position of the shades, colors, tones, or patterns on these spheres dictate the angle of which they will appear on your shapes. Change the glass material on your sphere to matte cap. Spline comes with a small set of default matte caps to experiment with. Try clicking on this gold one. Turn your lighting material down or all the way off. As you can see, when you rotate your perspective, the shiny reflective section of the gold matte cap stays on the top left section of your sphere, exactly as it appears in the flat 2D image. This matte cap is made to reproduce the look of a golden object, and it's what I used to create the gold rings that you saw in my gemstone animations. Move your ico to the left of your sphere and then create a thick helix as well, like so. Center, align, and distribute these objects so that they're lined up in a row. Right-click your sphere or its name on the list to the left, copy the material, and paste them to your other shapes. They appear to be affected in different ways, but the bright part remains on the top left and the dark on the bottom right. Since matte caps provide the complete look of the material within the image, matte cap materials have only one setting, rotation, which allows you to rotate the circle or image so that the surface rotates directions around to different sides of your shapes. Spline's matte cap selection is pretty small, but luckily I've created and accumulated a huge library of over 500 of my own matte caps. My library has a huge variety of realistic matte cap materials like metallics, opals, fabrics, skin tones, glossy and matte surfaces in all colors, and then also surfaces from everyday objects like wood grains, carbon fibers, fabrics, tiles, animal skins, psychedelic patterns, plastics, glowing materials, slimy ones, and so much more. Let's try a few of them out to see what's possible. Select your ico and try rounding out the corners a bit more. Then select all three of your objects and merge their geometries. This way, when we change the matte cap on one, they'll all change together. You can add and change your own matte caps just like adding images by clicking this upload button. Let's change our view to perspective because matte caps tend to look a little better this way. Alright, let's try out a few of the matte caps from my own personal library. This glossy plastic blue one is one of my favorites. Check this out. It creates this slick blue reflective look. As you can see, the sphere will always match the matte cap's photo almost exactly. Now let's try this slightly matte metallic one. It makes our sphere look a bit like a pinball, and the other shapes look metallic. Now check out this trippy rainbow pattern. Whoa, I think I'm hallucinating. Happy 60th anniversary to the Grateful Dead, and rest in peace to Phil Lesh. I'm going to cycle through a few more of my own personal matte caps quickly so you can see all the different things you can do. Here's an awesome wood grain material. Next, here's a glossy, slightly translucent blue one. Here's a padded black futuristic fabric material. And check out this awesome red dragon scale matte cap. Imagine this on a real dragon. Here's a great rocky effect for cobblestones or making cliffs in nature creations, or a rusty paneled metal that might look good on a rundown Millennium Falcon or old plane. I love this jawbreaker looking matte cap. It kind of looks like the scattered little plastic bits on garage floors. Or check out this purple glowing one with a black perimeter. These reflective glossy looks come in several different colors. Here's a brown leather one you could use for clothing or a wallet or a handbag. There's dozens of variations of these opalized effects and so much more. Just so you know, you can download a free sample pack of 50 matte caps for 100% free with all the matte caps I just showed you in my Patreon shop. No strings attached. You can test out all the ones I've just shown you and several more. If you like those, you can get all 500 of my matte caps from my personal library for only $8 or get them for free with any Patreon membership. I know we're all on a tight budget these days, but definitely don't miss out on the free sample pack. Here's a few examples of ways I've used matte caps in unexpected ways in my own spline builds. This car animation uses this pink matte cap on every piece of the vehicle. The smoke from the exhaust is a particle emitter, which we'll be covering soon. This retro radio I made has matte caps everywhere. A pink speaker, a blended green body, metallic two-tone on the hook, a rainbow material for the knob, yellow for the screws and border, and black mixed with glass materials for the screen. I modded all the shapes for this in Adobe Illustrator's new 3D tool section. A future chapter of this guide will cover all sorts of external tools that you can pair with Spline. For your matte cap homework, try applying them to some more complex shapes, like perhaps something you 3D modeled from our earlier lessons. We're covering patterns in the next video. Here's an example of some cool line and dot animations I made with patterns and some post-processing effects. We're also covering displace as well, the only material that changes the shape of your objects. Here's a small example of what displace can do. It's shown here mixed with a rainbow material, but there's so much more to displace. We're all done with materials next lesson. This is lesson 1.13, Intro to Materials Part 5, Patterns and Displace. Pattern, like its name suggests, creates patterns of several different kinds on the surfaces of your shapes and can be changed and edited in lots of fun ways. Displace, on the other hand, is a strange and unique material. It's the only material that changes the actual 3D structure and composition of your objects. It uses the same mathematical algorithms as the noise material, but applies it in a whole different way that morphs and distorts your shapes. So let's learn about them. I'm going to continue to explain each material, preview their effects on a sphere, and show you guys some of my favorite uses of them in my own work and the work of others to show you what's possible. Start this lesson with a new file, set the background to a fun color, and make a perfect sphere by holding Shift with the dimensions about 300, and finally reset its position to center it. This is where the setup will change a little bit. Change your color material to a rainbow one and set the X and Y offset settings to 700 to get a side view of the stripes. Increase the RGB settings however you'd like until you get some colors that you're happy with. Turn the frequency down to about 20. This will help us to see the effects of our next new material. Material number 14 is Displace. Displace is the only material that will change the physical shape and properties of your object. Displace uses the same mathematical equations as the noise material to create distortions like ripples, waves, and swells on the surface of your objects. These animations show a few examples of ways I've used the material to create motion, organic shapes, and liquid effects. Hit plus to add a new material and change it to Displace. We can already see its effect on the shape of our sphere. Because of its properties, Displace is the one material where position in the material stack makes no difference. Displace has no opacity and it can be only set to on or off. Its main setting, which changes opacity on other materials, instead adjusts the scale of the distortions, or what I call waves, on the object's surface. If you turn it up, you can see how it grows the waves on the surface of the sphere and affects the colors from our rainbow pattern as well. Displace's setting that is labeled scale actually adjusts the amount of these waves or distortion instead of the scale of them. Displace has 7 different types or algorithms that create patterns. Types like Simplex and FBM are more intense rippled effects, while Ashima and Perlin have bigger, bulging, blob-like waves. Once we learn more about the material as a whole, go back and experiment with each type to better understand their differences and unique styles. The movement setting changes the location of the pattern or where the equation reacts to your object. Adjusting it creates these fun movements as the effect passes through different parts of your shape. These offset settings allow you to create these movements in different desired directions. Movement and offset changes are a great way to animate your displacement materials on your objects. You can create all sorts of organic and liquid type effects this way. The 7th displacement type, Voronoi, has its own unique sets of types, settings, and effects. Voronoi is just another noise algorithm, but it has its own collection of styles within it that affect the displacement of your object in many different ways. The best way to learn about these types is by selecting and experimenting with each one as well. In Voronoi, the quality setting sets the quality of the application of the effect. Higher quality has a cleaner, smoother look, but also means a larger file size and more computing power. So this is something to consider if you're putting your project online. Increasing the sides of your shapes or its subdivision is another way to add smoothness. Seed randomizes or reshuffles the pattern without changing the other effects. It's a good way to get variety if you have multiple affected shapes. Smoothness affects how sharp or soft the transition between the cells are. If you want smooth flowing patterns, increase it. For sharp, edgy designs, keep it low. Next, the high and low cut settings are like contrast controls. High cut allows the waves to expand outwards when turned down, and low cut brings them inward when turned up. They reset the pattern when their adjusted numbers go past each other. The scale, movement, and offset settings work just like the other types. Displacement is an awesome, albeit somewhat strange material. It's great for adding a sense of natural or organic shapes to objects when used sparingly, and it's also a very good material for creating cool animations. Try changing the movement and offset settings between states in transition animations to create liquid effects, or something similar to what I did in this animation of pool and hot tub water. Displace only works, or at least only looks good, on round or organic shaped objects, like our sphere or shapes with their subdivisions turned up. This is because it causes flat surfaces on geometric shapes to rotate and disconnect on the edges and leave spaces between them, like shown here. So keep this in mind. Before we start our next material, delete your sphere and create a new one about 300 in size and reset to center it. Our final material is material number 15, pattern. Pattern is a pretty straightforward material. It allows you to add patterns of several different types to your shapes, such as stripes, checkers, or polka dots. Each pattern is made of only 2 colors, but you can stack them and add as many more as you'd like. Pattern is another material that is great by itself, but really shines when blended with other materials such as matte caps or rainbows to create different effects. Patterns come in 8 different types or styles, and they're pretty straightforward. Circle, ring, polygon, cross, diamond, checkerboard, line, and wave. These patterns can be applied or projected onto the shapes in 3 ways: UV, spherical, and triplanar. UV and spherical projections tend to look best on spheres or shapes with rounded faces, while triplanar often works well on shapes with flat planes like cubes and pyramids. But experiment with the projection settings on each unique shape to see how it applies. Apply the spherical projection to your sphere and try changing your pattern to line. This is how you go from spots to stripes. The spherical projection can be set to X, Y, or Z, which changes the direction of the pattern on your shape. The offset setting moves the pattern up or down or left and right on your shape. Each pattern is made of 2 colors. Try changing the black and white to make a colored stripe pattern. If you wanted to add more colors, like 3 colors of stripes, you can do so easily by duplicating your pattern layer like so, adding a new color and making one transparent. When you offset the new color, it becomes part of your pattern. Here's how you might do that. These color settings in your pattern materials work just like your color material does. Frequency changes how often the pattern repeats, and as a result, makes the pattern bigger or smaller in size as it increases or decreases. We can only change the Y frequency on these stripes because they're wrapping fully around the X-axis already. The size setting increases or decreases the size of the top color. Variation makes the patterns randomize in size, with the largest one being set by the size setting. Smoothness changes the pattern from distinct color changes to gradient or feathered ones. Rotation changes the angle or rotation of the pattern on your shape, like so. The vertical and horizontal settings allow you to apply patterns on only specific portions of your shape. These letters on the settings stand for top, bottom, left, and right. When they're set to 0 to 1, the whole shape is covered. These numbers can be set closer together to remove the pattern from certain parts of the shape. Some patterns, like circles, have this zigzag setting, which allows you to offset the patterns from itself, like so. The polygon pattern has a side setting that allows you to change the shapes from triangles with 3 sides to squares pentagons, octagons, and beyond. Now that we've learned how to create patterns on a sphere, try practicing on a cube or a helix and some other shapes. Try out different projections and styles on each shape. Then try using the opacity to combine patterns with other materials and switching up the blending modes. You've now learned how to use all the materials. Congrats to everyone who's made it this far in the Spline guide. You know all the basics of the program, how to 3D model anything you can imagine, use materials to make it look incredible, and even animate it to do awesome things. This is lesson 1.14, post-processing effects. You guys should start this lesson a little bit differently than usual. Find me in the Spline community by clicking community on the left menu of the program's homepage and searching Spline Guide Effects up top. Click this file with the yellow background and then click the follow button here on the left so you can access all my free Spline builds, assets, and materials in the future. And finally, click this blue remix button to open the file I created for this lesson. It will appear as a tab up top. Click that to open it and you'll be inside of my project. It will have all the effects turned off, but you'll be able to activate each one and see how they affect the file and my animation by clicking play. Don't worry, by remixing the file, it will be duplicated, so you won't change anything on my end or affect anyone else trying to access it. Also, keep in mind you can remix it again as many times as you want, so you can make all sorts of changes and remix it again whenever you need a fresh start. In Spline, the quickest way to access effects is to click your background or the empty black space on the bottom of the left menu to access the main right menu. Click the toggle next to the word effects to open up the list. They're activated by clicking the eyeball on the right side, and their settings, strength, and blending modes work just like materials. You can use just one or combine as many as you like, applying and removing them at any time during your work. You can also turn them on and off all at once by clicking the main toggle next to effects. This lesson will work like this. I'll start by showing you what each effect does with examples of my animations side by side with and without each effect. And then we'll cover how to use and go into detail about each one. We'll cover the purpose, strength, and unique settings of each effect, and then we'll finish by covering the extensive list of blending modes, which the list is the same, but the results are quite different for each and every effect. Effect number 1 is DOF, or depth of field, which photographers will be familiar with. Depth of field allows you to focus on a specific portion of distance from your perspective. This distance can be set near or far and precise or wide. It makes everything at a specific distance sharp and crisp and in focus and blurs the areas that are too close or too far away. It's a photography technique, and f-stops or apertures on cameras are what help you achieve these desired results along with proper lenses, etc. You can see how a specific area is in focus while the foreground and background are out of focus or outside of that depth of field in this comparison. Depth of field as an effect tends to look better in perspective rather than orthographic mode. We haven't discussed this much, but as a rule of thumb, orthographic is a setting best applied in stuff like website builds and assets, while perspective is more for realistic three-dimensional scenes. The focus distance setting controls the area that is in focus. The best way to set your focus is by clicking the target next to the setting and selecting a spot in your scene. Think of this target almost like an eyedropper tool, but for distance instead of color. You can change this setting the same way you would any other one, but the target is a great tool. Once you select your focus distance, the DOF, or depth of field setting, allows you to choose the size of the area that is in focus. For example, you could increase it to focus on multiple objects or decrease it to focus on only a portion of a single object. Finally, the blur setting determines how extreme the blurriness is in the unfocused areas. Here's a quick pro tip. Many of Spline's settings seem to max out when you move the toggle to the end of the setting spectrum. However, if you move your mouse over the number section and get this double arrow to appear, you can move these settings way beyond their apparent maximum, at least in some cases. Effect number 2 is pixelation. Pixelation turns your scene into square pixels of different sizes. The granularity setting determines the size of these pixels. This effect tends to change a little bit in pixel size when you hit play or export, so keep that in mind. The pixel size you see when you hit play will be the actual output of the effect and not what you see in build mode. So be sure you like the size of what you see in play mode. Effect number 3 is aberration. Aberration splits the RGB, or red, green, and blue layers of your scene in different directions. Digital screens are made up of thousands of tiny red, green, and blue LEDs, which trick our eyes into seeing all the colors of the rainbow by combining different levels of brightness. Aberration separates these 3 color layers into different directions. The offset settings move these layers around in different directions, and the numbers can be set to negative and positive. The further from 0 they go, the further the layers will split. The red and green layers will skew to the outside, leaving the blue layer in the center. Number 4 is bloom. Bloom adds a glowing highlight to the brightest parts of the entire scene depending
on the settings. Size determines the size of the glow, or how far the glow spreads around the bright areas. Intensity controls the strength or effect of the glow. Blur adjusts how blurred or sharp this glow appears, and modifies the overall brightness of the bloom relative to the scene. Threshold sets the brightness level required for areas to emit the glow, and increasing it makes darker areas glow. Smoothing finally balances the transition between the glowing and non-glowing areas. Number 5 is hue. Hue changes the colors of your scene across the full spectrum of the rainbow. So for example, something that's pink can turn to any other color on the spectrum, and all other different colored objects will change the same amount relative depending on their color. It's a ton of fun to play with, but it can get confusing because when your color or backgrounds are set to one color and the hue effect is on, it's hard to know how to change them properly because they won't be matching. Sometimes it's best to test hue by turning it off and then adding it once you're finished, or just turning it on for a brief moment to check how your scene looks. Hue also has a saturation setting, which will boost or gray your colors. Material number 6 is brightness. Brightness is exactly what it sounds. It turns the brightness or exposure of your scene up and down to be lighter or darker. It also has a contrast settings to make these changes as well. Adjusting hues, saturation, and brightness's contrast can help you achieve some cool different looks, so try using those two things together. Number 7 is vignette, another thing film photographers will be familiar with. It adds dark corners to your scene like an old Polaroid photograph might do. It works best for a retro vibe. You can change the darkness up and down with the darkness setting. Offset is actually more of a feathering or a blurring effect than an offset effect. Finally, number 8 is noise. Noise is another descendant of film photography, like depth of field, brightness, and vignette. Noise adds a film grain or static effect to your scene. When it's turned up to 100, it's way too much generally. But if you set it down to between 5 and 10, you can get some really cool looks which will take away from the strange, sharp look of Spline's 3D scene or models without making your scene look blurry. I like to use it for a lot of my animations because it somehow seems more realistic to me. All effects have blending modes just like materials. They actually have much more, and they all work very differently. And all effects blending modes are set to normal by default, and you can change them by clicking the interlocking circles. To be honest, these blending modes still confuse the heck out of me, and I barely understand them myself, and each one does a different thing to each different effect. I would not presume to even try to teach you guys about them from my knowledge. The best way to learn is by experimenting with them, like most things in Spline. But since I want to try my best to give you guys all the info, I got some somewhat confusing answers from ChatGPT that may be helpful to you, so here goes those. Normal is the default blending mode and applies the effect directly. Skip essentially turns off the effect. Add intensifies by adding the effect's output to the original view. It's great for glowing or brightening. Alpha modulates the effect based on transparency. Average blends the effect and the original view by averaging their values. Color burn darkens the base dramatically based on the effect's intensity. Color dodge brightens the base based on the effect's highlights. Darken retains only the darker values from the base of the effect. Difference creates a contrasty or inverted look by subtracting the values between the effect and the base view. Exclusion is similar to difference but with a softer and less harsh result. Lighten retains the lighter values between the effect and the base view. Multiply enhances the shadows and dark areas by multiplying the values of the dark areas of the effect and original view. Divide creates a brightening effect by dividing the effect's output by the base view. Negation inverts colors based on the interaction of the effect and the original base view. Overlay adjusts contrasts by combining multiply for darks and screen for lights. Reflect amplifies highlights by dividing the effect by the base view. Screen brightens the result of the effect by inverting and multiplying the effect by the base view. Soft light applies a subtle soft lightening or darkening based on the effect's influence. Subtract removes the effect's output from the base layer, creating a darkening effect. If you see these black and gray checkerboards appear while you're changing or experimenting with blending modes, it means those portions of, or sometimes the entirety of your scene, is transparent or effectively non-existent. This is generally not a good thing, so try to avoid them unless you really know what you're doing or have a purpose for them being there. They tend to show up on negation, difference, divide, and exclusion blending modes, and especially in bloom and brightness effects. I should say quickly, this remix process is a fantastic way to teach yourself about about all sorts of different things in Spline. The community has a ton of incredible projects by some brilliant artists. Spline highlights awesome creators in the community every week, and you can remix and dissect all the projects to see the entire back end of how each one of them are built. Searching for specific aspects of the program works a lot like Instagram's hashtag, and it's a wonderful way to discover all sorts of techniques that you want to learn or creators doing awesome and innovative designs on Spline. I highly recommend taking some time to do this and being an active part of this community.
This is lesson 1.15, light and shadow. Lighting objects, directional, spot, and point lights. To start this lesson, head over to the Spline community on the left side of the main page. Search for Spline Guide Light up top. Click this scene with the blue background to access my file. Hit the follow button on the left so you can remix all my Spline files and get the material assets from them in future lessons. Then tap the remix button to open the lesson scene. It will appear as a new tab up top. Click it to open it up. Once inside, you'll see a grid of dodecahedrons 5x5 spaced apart with a flat square in the background. We're going to use this setup to explore Spline's 3 different light objects and their properties. Every Spline file starts with a directional light by default. However, when you open this scene, you'll notice that all 3 lighting objects are turned off, yet there still seems to be some source of light and shadows going on. This is from ambient light and ambient shadows. Click your background to access these settings in the right menu. Ambient light is a type of light that illuminates the entire scene uniformly without a specific direction or source. It simulates the general light that bounces off surfaces in the real world, providing base level brightness. It doesn't cast shadows or come from a particular angle. It creates a scene-wide illumination and ensures that no areas of the scene are completely dark unless explicitly modified to do so. It is adjustable in intensity and color to control the brightness, tint, and tone of the ambient light to suit the scene's mood. You can use it for adding a layer of uniform lighting before refining the scene with other light types and setting the overall tone of your scene, for example, to be warm, cool, or neutral. Turning it off without other light sources will make all objects in complete darkness. The shadow setting adjusts the quality of the shadows it creates, and a higher setting requires more computing power but creates more realistic shadows. Ambient shadows are the subtle shadows that appear from the ambient light where objects are close to each other. They add depth and realism by simulating the way light behaves in crevices or near surfaces. The radius and bias settings allow you to affect how the shadows are cast on objects and their darkness, etc. The tint, color, and tone of these shadows can be adjusted as well, as you can see here. The shadow setting adjusts the quality of these shadows just like in ambient lighting. You can combine ambient lighting and ambient shadows effectively to make your 3D scenes in Spline feel more polished, natural, and immersive. Okay, now let's discuss the lighting objects. They've already been added to this scene. There are 3 types of lighting objects in Spline: directional light, point light, and spotlight. You can add these lights to your scene just like any other 3D shape. Click the plus sign and scroll to the bottom to find the lighting objects. All lighting objects have customable properties and settings in the right-hand menu. You can combine multiple lights to create more realistic, balanced lighting effects, and lights can be animated or used in events to change properties like movement, color, intensity, and more. The first lighting objects are directional lights. Click the closed eye next to it on the left menu to make it appear. Every Spline scene starts off with a directional light. It always points towards the center of the scene, or 0, 0, 0. When you move it, the line you see shows the light's direction. Directional lights simulate distant light sources like the sun, casting parallel rays. Their light remains consistent across the entire scene without fading over distance. The directional light in this scene starts off centered, pointing towards the grid of shapes and casting shadows of them on the wall behind. Try selecting the light and moving it up and down or left and right to see the shadows react and move across the wall based on the light's direction. All lighting objects have color and intensity settings. Color adjusts the hue and shade of the light, and you can change it just like your color materials. Intensity increases or decreases the brightness of the light, as you can see here. Higher intensities will push colored lights towards white. Shadows from directional lights are consistent and parallel. All light objects have a shadow section as well, which controls whether or not that specific light casts shadows of objects onto other objects from that light. Shadow can be turned off and on for each light source. The resolution setting sets the light's resolution. Larger settings will cast sharper shadows. Size sets the size of the light,
as seen here when turned down. Blur adjusts the sharpness of the edges of the shadows cast by that light. Increasing it will feather the edges of these shadows. Penumbra refers to the soft, partially shaded area around the edges of a shadow. In the context of lighting, it describes the gradual transition between full shadow and full illumination. It's a gradient between the two. This creates a more natural and realistic effect, as light rarely produces a perfectly sharp shadow in real-world scenarios. For a fun experiment, try creating 3 different colored directional lights like pink, yellow, and blue, and projecting them from different angles like this. See how they create different colored shadows where the objects are illuminated by 1, 2, 3, or no lights at all. Another cool trick to know is that all objects have shadow settings, and you can choose whether they cast or receive shadows by turning these settings off and on. Now let's hide the directional light and show the point light. Lighting object number 2 are point lights. Point lights emit a light evenly in all directions from a single point, sort of like a light bulb, and they're best for illuminating specific areas or objects. They're perfect for localized light sources like lamps, candles, or glowing objects. Our point light is perfectly centered in the middle of the scene and the grid of shapes, and you can see it illuminating the center of the grid and casting shadows of the shapes on the wall. Try selecting it on the left menu and moving it around with the arrows to see the shadows change. Try changing its color too for fun. If you move it out from the grid towards the wall, you can effectively see an intersection of the sphere that it creates cast on the wall. As you move further from the wall, that intersection gets smaller. This is because a smaller portion of the sphere is cast on the wall. The distance setting sets how far the light reaches, or the size of this imaginary sphere. Decay reduces the brightness near the edges of this sphere. When you slide the toggle, it changes in whole numbers, but you can type in settings of numbers 2 past the decimal point, like 0.15 for example, or any other number. Radius softens the shadows when increased, creating a more diffused light. Here's an example of an animation I made using point lights. I grouped point lights with these spheres to give the illusion that the spheres themselves were glowing with light as they move around the scene. I have a tutorial on my channel about doing this if you want to learn how to do it for yourself. Now let's hide our point light and show the spotlight. Our final and third light type are spotlights. Spotlights emit a focused cone of light, similar to stage or theater lighting. You can see the cone represented in your scene like a line for directional lights. Spotlights are best for highlighting specific features and adding dramatic effects to your scene. Our spotlight is shining through the grid of shapes, and you can see a crisp circle of the end of the cone on the wall. Try moving the spotlight up and down and left and right and rotating its angle or direction to get different looks of the shadows of the shapes on the wall. The distance setting adjusts how far the light reaches. If you lower it, you will see a circle appear representing the end of this distance. Angle opens and closes the size of the cone and how wide the light's angle is. Edge blur softens the outer edge of the light cone for a smoother appearance. Decay reduces the brightness over the distance of the cone, creating a natural fall off of light. When spotlights illuminate a surface from an angle, the circle will distort and stretch across the surface just like a real light would. Try moving your light to an angle and illuminating the wall this way. Next, click the eyeballs to try hiding the dodecahedron grid and the spotlight, making only the group and the wall visible, and then hit play. This is an example of what animated color spotlights can look like. Here's another example of me using spotlights in my own animation work. I use the spotlights to create a live music stage. I actually paired the spotlights with semi-transparent cone objects to create those glowing triangles you see at concerts. I'll put this file in the Spline community so you can remix it and see the inside of how it works. Lights and lighting objects are fundamental for creating realistic and dynamic scenes in Spline. Be sure to experiment with the combinations of directional, spot, and point lights to achieve different kinds of awesome effects in your designs. For your homework, try creating a scene of your own with different kinds of lighting and see if you can change the mood of the same scene by lighting it in different ways. This is lesson 1.16, framing and exporting. Images, videos, 3D models, files, websites, and more. So you have your Spline project finished. You're happy with how it looks when you hit play, whether it's a still design, motion graphic, or interactive build. But before you save and export it, you need it to be the perfect size for your image, TikTok, YouTube video, or website. Or maybe you need it to be some strange size or custom shape. Here's how you do that. Click the bottom empty space in the left menu to access the main right menu. Up top, the word frame will appear. Click the drop-down menu where it says responsive. This full HD option beneath the word custom is the standard video size. It's the correct proportion for YouTube videos. If you want to scale the video up or down, you can click this lock button next to the dimensions to lock it. Now when you change the width, the height will change in perfect proportion. Above this size setting, the word guide has appeared. This guide shows exactly where your frame's outer limits are. You can turn it on and off by clicking this eyeball and change the color and opacity to your preference to help you envision what's inside and outside of your frame. In the size list, there are options for custom sizes, TikToks, Twitter images, Facebook posts, LinkedIn, and the exact screen proportions for all kinds of smartphones, tablets, and electronics. Maybe you want to make a TikTok reel or short. This TikTok setting is the perfect 16:9 ratio you need for these videos. Select it to get this tall frame. You may need to readjust your scene after changing the frame, so it's usually best to start creating with your frame set up in the beginning. Once you're happy with your framing in play mode, it's time to export your creation. We'll start with images. For images, set up your scene so you're happy with the image in the frame. Hit export and scroll down to image. You can export JPEGs and PNGs. Select which one you prefer. You can increase the ratio to multiply the pixel size of your image. With PNGs, you can choose to hide your background color so the image is transparent anywhere the background is visible in your scene. Hit export and save the file like any other file. You now have your image saved. For videos and animations, select export, then video recording. You can export WebM, MP4, or GIF file types. You can also export image sequences, which will save individual images for each frame of your video. Select the frames per second or FPS you prefer. 30 and 60 are standard FPS settings. Mbits increase the quality and file size of your video. The fixed setting allows you to select the exact length of your video by recording in seconds. The toggle only goes to 10 or 20, but you can enter larger numbers by typing them in. Longer videos and higher FPS or Mbit settings are more likely to glitch, crash Spline, or freeze your computer, so keep that in mind. Try to keep videos to 30 or 60 seconds. For longer videos, sometimes it's best to export them 30 seconds at a time and do them in multiple parts. It's generally better to leave the settings below these alone and just record the video as is. If you have glass in your build, you can scroll down and select the glass precision to be higher for better results. Click export and then click the red recording circle to record your video. Once it's done, it will process and you'll be able to save your video just like any file. Spline can export 3D models or files for 3D printing. These file types are GLB, GLTF, STL, and USDZ 3D file types. To export your 3D model as these files, have a single 3D object in your scene, set it to the center, and click export to export it. You'll need to have Spline upgraded to export these files. Spline files or .spline files can also be exported and saved to your computer or hard drive if you wish to have a local copy of your file. You can attach these to emails, share them, or zip them up to ensure you have access to the local file offline or when you don't have access to Spline. Public URLs. Every Spline file has a URL which you can use to view or share the raw file online. When you're happy with your project, click Update at the bottom to update the public URL and save its online form. Then copy the URL or click this arrow next to it to view it. As you can see, these projects are still interactive online and can be zoomed, orbited, panned, and much more. You can turn these settings off if you wish in Play Settings, along with many other customizable options. As you can see, there can sometimes be issues with the raw viewer in Spline in certain projects, especially ones with cameras and animation. You can see the problem here with the misaligned ski balls in my animation. These problems can be solved, but sometimes need to be fixed with coding or on various web platforms in most cases, which I'm not an expert at just yet. For the web, Spline also has a Spline Viewer embed code exporter and a beta version for coding formats like React, Vanilla, Next, 3, and more. They also have beta exporters for Apple iOS and Android platforms for websites, applications, and even the Apple Vision Pro goggles. I don't know enough to teach you guys about this stuff just yet, but I'll put a link to the Spline documents page on the screen now and below in the description where you can try and get some more info until I'm versed enough to do another lesson on them. This is lesson 1.17, cameras, setting and animating the viewpoint and perspective in a scene. Cameras are super easy and fun to use for anyone who is already familiar with working with other 3D objects and has a little bit of knowledge about animation. You can almost think about cameras like the spotlights, which we just learned about, that have a specific distance, angle, and direction. but instead of lighting your scene, they show it. To start this lesson, you can use any Spline project that you've already built. If you don't have one, I've made the file that I'm using for this lesson available in the Spline community, and you can access it by searching Spline Guide 1.17 Radio. Click this scene with the blue background, hit the follow button on the left to follow me in Spline, and then click the remix button on the right and open the scene by clicking the tab that has appeared up top. This is a little retro radio which I built. Many of the pieces were actually created using Adobe Illustrator's 3D tools and then imported to Spline. A future chapter of this guide will cover all my favorite external tools that I like to pair with Spline, so look out for that in the future. As I mentioned, cameras are ways to control your perspectives in Spline and can be animated to move around. I used the camera in this scene of a ball rolling down a spiral tube, and I animated the camera to follow its journey through the glass tunnel. This specific scene was created using Spline's physics simulator, which allows you to add gravity to your creations. We'll be covering physics in the next couple of lessons, and I'm already working hard on editing that one. Adding a camera is simple and can be done in two ways. You can go to the top toolbar and click the plus button to add a camera object from the bottom near the lights. But the easier way to do this is to click the viewport drop-down list in the top right menu. Under personal camera, it will say add new camera. Click it and you'll see the word camera has appeared and there's a camera object on the left menu. You are now viewing your scene through this camera. Just like your regular perspective in Spline, cameras can be set to orthographic or perspective mode. I prefer perspective for 3D scenes. Now click the viewport menu again and select personal camera. You're back to your personal viewport. If you pan and rotate to the right and zoom out a little bit, you can actually see your camera's position in the 3D space, as long as it is still selected or highlighted in blue in the left menu. The yellow box represents the camera's view and direction. You can now move and rotate your camera if you wish, just like any other object. When your camera is selected and you're in personal view mode, a tiny frame will appear on the bottom left and show the camera's view, giving you two options. Both seem to do the same thing, but here's what the difference is. Snap to camera moves your personal viewpoint to match the view of the camera. Use this camera actually changes your viewport back to the camera itself. Listen up carefully here because this is important. If you're happy with your camera's view and you don't want it changed, but you still need to move about your scene for edits, make sure to do this in personal view mode. If you forget to do this and you move around, you will reset the position of your camera in whatever state it's in. If you're forgetful about this kind of thing, just click the lock button next to the eyeball on the camera in the left menu to ensure you don't forget. In Spline's perspective camera settings, the near and far settings define the camera's clipping planes, the minimum and maximum distances at which objects are visible in the scene. Here's what each does. Watch as I scroll very close to the radio speaker. You'll notice the speaker holes start to get cut off in the view in the camera's default perspective settings. This is because of the near setting. If you turn the near settings number down, it will ensure that closer objects are within the view, no matter how near it may be to the camera. As you can see now, there's no more clipping of the speaker. The far setting does the reverse of this. Turning down the far setting will show less and less of objects in the far distance of your scene, and turning it up will make them visible again. The FOV setting sets the camera's field of vision to wider or smaller angles. This changes the camera's vision or viewpoint without changing its position in 3D space. The FOV setting cannot be animated, so if you have multiple states, changing it in one will change it in all other states. The zoom setting is quite similar to the FOV setting in this way. It changes the viewpoint framing by widening and shrinking it. The toggle on the zoom setting is extremely sensitive and makes extreme changes even with the smallest of movements. For this reason, it's generally better to type in the numbers you want applied in the text box to the left of the toggle. The zoom setting, unlike the FOV setting, can be changed from state to state when making animations. However, the zoom setting in extreme cases can cause a phenomenon known to photographers as parallax or foreshortening, which alters the proportions of certain objects in the frame as well as their apparent distance and relation to one another. This animation is an example of the parallax effect that is caused when you move the camera far away and zoom in, or move it close and zoom out. Now let's do some experiments with animating the camera. Zoom out far away from the radio by scrolling backward. You should see the Z-axis position numbers change. Now click the plus sign next to state in the right menu to add a new state to the camera. Select state under base state and zoom into the radio or whatever subject is in the scene that you're using. Now click the plus sign next to the word event to add a new event. Select transition, change the word current to base state, and change the seconds to 5. And now hit play. Your camera is now animated to move towards your subject. Now let's try something a little cooler. With state selected, change the Z rotation to about 360. Now hit play again. Your camera is now animated to rotate in a full loop as it zooms closer to your subject. Pretty cool, right? All the positions and rotations and zoom of your camera can be changed for each state, and you can add as many states as you like. Now let's try to recreate the parallax effect. Delete your state. Change the zoom setting under perspective to 80 so you're extremely close to the speaker. Now set your Y position to 40 and set your Z position to 24,000. 24 with 3 zeros. All other position and rotation numbers should be 0. If you're using your own scene, just make sure it's centered in the scene like this with the zoom at 80. Now click to add a new state again. Change the zoom on this state back to 1. Now click the word reset in the bottom to reset your camera's view. Keep the Y setting at 40 and change the Z position to 500. And make sure the rest of the rotation and position numbers are 0. The radio should be centered in your scene again. Now open up your transition event and set number 2 to state again and hit play. You'll see how the black platform seems to lengthen drastically under the radio. This is the parallax effect. This is a very fun effect, and you should use what you learned here to experiment with this and see what kinds of other things you can do by making different changes. Cameras can also be animated to follow a path created with the Path tool. If you have a path created, select your camera and click Align to Path and choose your path, usually titled Shape by default. Select the slide setting to 0 in the base state and change it up to 1 in the state. Click the eyeball next to the path or shape in the left menu to ensure it's invisible and not in the scene. And the camera will slide along the path that you've created. You can also add multiple cameras to your scene. Really quickly, let's learn about changing shots with multiple cameras. Make a simple 5-second animation with your first camera like so. Now click to add a new camera. Camera 2 will appear in the left menu. Make a totally different 5-second animation in camera 2, like this one that zoomed in on the speaker. Make this animation 5 seconds as well, and set the delay at the bottom of this animation to 5, as that is the length of our first camera animation. Go back to your first camera and add a new second event and choose the switch camera option. Set the target to camera 2 and set the delay to 5. Turn the animate option off. Animate will animate the transition from one camera to the next, and we don't want that in this case. We want a hard cut from one to the other. When you hit play, the first camera's animation will play, and then it will hard cut to our second camera's animation. Pretty cool. Finally, you should be aware you can add as many states to your camera's animation as you want, like I'm doing here. Change the settings in each state, and then click the plus sign to add new states in your transition event to animate them from state to state. The possibilities are endless. One last thing to note before we finish, don't forget about the depth of field effect that we learned in lesson 1.14. Depth of field is an awesome effect to pair with camera animations. So be sure to take a shot experimenting with that. For your homework, practice all the things that we've learned and experiment with changing the rotation, position, FOV, and zoom settings of your camera. Try creating align to path camera movements or filming other objects that are already moving and animated in your scene. This is lesson 1.18, physics, gravity, collision, weight, friction, bounce, and more. Here are a few examples of some of my favorite spline projects that use the physics simulator in cool ways. This first one is basic, but I think it's a pretty cool one. This is an animation of a marble rolling through a glass tube which I created from a path. The marble is set to dynamic, which means gravity affects it. The spiral tube is positioned, which means it's stationary or unaffected by the physics engine. From the physics gravity, the marble falls into the tube and rolls all the way down and out the bottom of this tunnel. I animated the camera to follow its journey in this piece as well. I have an old tutorial about how to build this project on your own if you'd like, and I'll put a link on the screen right now. This next animation is a small Rube Goldberg machine. The dominoes fall and topple each other over before finally knocking this pinball down a ramp. The platform and ramp are positioned in this case, and the dominoes in pinball are dynamic. This next animation is actually from my first time experimenting with physics in Spline. It's similar to the first one, but it has a basketball that rolls through a tube and down through a basketball hoop, which I animated to swish and added a little sound as well. I tried my best to get a realistic bounce on the court at the end. I don't think it's too bad for a first try. Finally, this last example is pretty interesting. I made a tiny little felt green craps table with a realistic red translucent casino dice. This project is actually interactive and uses an event called drag and drop. This event lets you grab the dice with your mouse and roll it on the table. It uses physics settings like bounce, gravity, and friction to get a more realistic dice roll. We'll be covering more events and interactive skills like this very soon, so keep an eye out for those new lessons. If you're already subscribed to my channel, click the bell beneath this video to be notified when new lessons come out. If you're not subscribed, what are you waiting for? Okay, now let's start this lesson. Start by creating a new file and set the background to a fun color. Go to the right sidebar menu and locate the word simulation and click on the arrow next to it to open it. Select the word yes next to physics to turn it on and enable physics in your scene. The gravity is set to -10 by default. Negative gravity means that the pull of gravity pulls downward like natural gravity does. You can set gravity to positive numbers to inverse the gravity or move it deeper into the negative numbers for a stronger pull of gravity. Now let's create a large cube in our scene. Reset its position to center it and then scale down its y-axis so it becomes kind of a flat floor surface. Select the cube and then scroll down to the bottom of the right menu to find the physics section. The following parameters will be visible and can be adjusted. Enable enables or disables physics. When set to based on visibility, it means the physics are only active when visible in your scene. This helps to keep file sizes smaller. You can set this one to on and off as well if you wish. The children setting only applies to groups. Groups will behave as a single object when children is set to fused. With separate turned on, grouped objects will behave individually. Body type. By default, all objects are set to positioned, which means that they will not react to the physics simulator or gravity forces unless you change the body type to dynamic. The dynamic setting means that physics will affect your objects. We want to keep our floor positioned, which means that even though it's floating in space, it will not react to gravity. Collider controls the collision types, and setting it to precise will make collisions slower. Next, let's make a sphere. Make it somewhat small in proportion to our floor, add a fun color to it, and then reset its position to center it in the middle of our scene, and then pull up on its y-axis arrow so it's lifted way above your floor. Scroll out if you need to, and pull it up a little more. With your sphere selected, scroll down to its physics settings and change it to dynamic. Our sphere will now react to gravity. You'll see a whole new list of physics settings will appear in our dynamic object. Weight controls the weight of an object, which means heavier objects will fall faster. The gravity scale controls the force of gravity on a particular object. The number multiplies the gravity's force by that number. It is somewhat similar to weight. Friction controls the amount of friction on the surface of an object. The less friction you set, the more the object will move across the surface. Super low friction will make objects look like they're slipping on ice, and higher friction will make them resist movement on a surface. Damping will make an object fall slower when increased. Bounce will make objects bounce higher when they hit a surface when its value is increased. Translation constrains the positional movement based on each axis. For example, if you turn X and Z off, the object will only be able to fall and bounce straight up and down on the Y-axis. Rotation constrains the angular movement based on the axis. You can use this setting to make an object pivot on an axis while gravity affects the unactivated ones. We'll learn more about these settings along the course of this lesson. Let's set our sphere's weight to about 1.5, move its friction down to about 0.3, and set its bounce to about 0.7. Now press play. Our sphere will fall down from the force of gravity, bounce off our floor a couple times, and eventually roll off the edge. Congratulations, you just made your first physics animation. Now let's try a few more experiments. Let's learn about the translation settings. With your sphere selected, turn off the X and Z option, leaving only Y on or in blue. Turn the bounce up a little if you want and hit play again. Now our sphere can only bounce directly up and down on the Y-axis. It will never move or roll off the edge. Next, if you try turning just X and Y on and hit play, you'll see the sphere is only able to bounce and roll off the edge in the exact center of the X-axis because it can't move back and forth in the other direction on the Z-axis. Next, let's learn about the rotation setting. For this one, we're going to set our floor to dynamic as well. We're going to turn off X, Y, and Z in the translation setting. This will make it so that it can't fall by the force of gravity. Now we're going to turn off X and Y on the rotation settings, leaving only the Z axis in blue. This will make it so that our floor can only pivot on the Z axis. Move your sphere towards the close edge of the floor so that it will fall off to the one side of the floor. Increase the size of your sphere a little bit and turn its weight all the way up to 2 as well. Hit play again. Your floor's translation is off, so gravity will have no effect on it. As the ball falls on the one side of the floor can only pivot on the Z axis, so it will spin around on that pivot point from the collision with the ball. For our next experiment, delete everything, make sure physics is still turned on, and make a new cube. We're going to make another floor. Reset its position and rotation to center it, turn down the corners, and then turn down its Y setting again to make a flat floor. Make this one slightly longer than wide this time. This floor is going to stay positioned. Click your background and go to Global Settings in the right menu and turn on Object next to the word Snapping. Now make another cube of any size again. Turn down the corners, and then you're going to set the size to X30, Y80, and Z10. This is going to be a domino. Now you're going to right-click this cube and reset its position and rotation as well. It will be centered and stuck in the middle of the floor. Now we can add a little normal material map to give it some fun colors. Rotate it 90 degrees by holding Shift so that it's facing the long ways direction on our floor. If the relative proportions of the domino and floor don't look like mine, click the lock button next to scale and resize it. Pull your domino up by the Y-axis until you see a tiny orange rectangle around its base and a wide one around the edge of the floor. That's how you know that it's perfectly standing and set on top of the floor at its base. Now use the arrow to pull your domino towards the close edge of the floor to about the 80% mark, like so. Now we're going to use the cloner tool, which we haven't learned about yet, but we will in an upcoming lesson. Here's a little preview. Turn this cloner toggle on. The cloner tool duplicates your shapes. Change the setting in X to 0 and change the setting of Z to 30. Now you're going to move the count up to about 12 or until they reach close to the edge. The 30 setting means they're 30 spaces apart. Now click the Convert to Instances button beneath, which will make each domino an individual shape. Go over to the left menu and select the original Cube 2, which will have 4 squares next to it on the left menu, and delete it. This is going to leave only the cloned cubes. Right-click Cube Clones in the left menu and select Ungroup to ungroup them so they're all separated on a list. Click the top one, hold Shift, and then select the bottom one as well, so that they're all selected in blue at once. You're going to go over to the physics setting at the bottom and set them all to dynamic. This means they're going to be affected by our physics simulator. With all of them still selected, turn their weight up to about 1.5. Now we're going to make a little ramp section at the end of our floor. Select the floor, click the Smooth and Edit button in the right menu, and turn the Subdivision modifier back down to 0. Select the Loop Cut option up top that we learned about in 3D modeling, and cut a loop in the middle of the floor, and then slide it down towards the end of your floor, past the first domino at about the 80% point. Now choose the Edge Select option up top, and choose the outside edge of the floor closest to you, and pull it up so it looks like mine. Now triple-click the background to get out of editing mode. Select your floor again, add a fun color to it of any kind as well. And now, to better see the ramp we made, move your perspective around a little bit, and set the visibility settings to flat, so you can see the angle of the ramp that we just created. Now we're going to create another sphere. Click the sphere button and hold Shift to make its proportions look slightly like mine. Add a color to it, reset its rotation and position as well. It's going to wind up lined up in the middle of the floor. Now you're going to move it up to about the middle of the dominoes, then move it down so it's above about the middle section of the ramp. Now you're going to move it up into the sky above the ramp. With the sphere still selected, we're going to scroll down to physics and set it to dynamic, which means it's going to be affected by gravity. Change its weight to 5 and change its bounce to about 40 or 50. Now, whichever direction moves side to side like this, which in my case is the Z-axis, we're going to make sure that that is set to 0, so it's perfectly centered. Next, what we're going to do is turn that axis off in the transition setting under physics, so it can't move back and forth on that axis. Now we're going to select all our dominoes again and move move them a little closer to the edge, so when the final domino falls, it'll fall off the edge of the floor. Now you can click play. Our sphere will fall, bounce off the ramp, knock down the first dominoes, which will knock each domino down in turn, and finally knock the final domino off of the edge. This physics animation you just made combines gravity, collision, weight, friction, and bounce all in one. You've now learned the basics of all the laws in Spline's physics simulator engine. Congratulations. For your homework, try messing around with all the tools that you learned. Maybe try building a simple Rube Goldberg machine or an interactive game. If you make something cool, tag me at the motion visual on Instagram or TikTok because I'd love to see it. This is lesson 1.19, cloners. Radial, linear, grid, and object cloning tools. Today we're learning all about Spline's cloner. The cloner tool is a powerful feature that allows you to duplicate objects systematically to create patterns, grids, or arrays. The multiples or clones of your shape are like ghost copies and do not add much additional file space to your project. With different settings, you can make these clone copies of your shape organized or chaotic. The cloner tool is perfect for creating repetitive copies of objects in your scene, such as a building with many windows or a pile of something. Here's a few examples of my animations that use the cloner tool. To start this lesson, create a new file, add a fun color to the background, and then add a shape. I'm going to use an icosahedron. Hold shift when you make it to make its dimensions proportional, right click it and reset its position so it's perfectly centered. Change your view to perspective and then add a matte cap or some colors to your shape. I'm going to add a normal map to mine. And then I'm actually going to change the hue effect on because I like the way this blue looks with the normal map. Okay, so now we got a shape in the center. That's all you need. With your shape selected, find the toggle next to the word cloner on the bottom of the right menu and turn it on. There are 4 types of cloners: radial, linear, grid, and object cloners. The default cloner is linear, but let's start with the radial type by selecting it from the drop-down menu and choosing it at the top of the list. Our first cloner type is the radial cloner. The radial cloner makes a circle with the clones or duplicates of your object, as you can see here. As you can see, if I click the word hide in the base setting, it will hide the base object in the center or the cloned object. If you click show, it will show it in the center. This base is your object that is being cloned, so you can choose to show or hide it. The count is the number of clones that are created with the cloner tool. Change this number to add more or less shapes to your circle. You can use the radius setting to make the radius of your circle bigger and smaller if you like. And you can move the number down so much that the shapes are intersecting with each other, which is a pretty cool look, I think. You can also change the start and end point of your circle in the settings. If you want to make a half circle or make other changes, then you can change these numbers back and forth to get different sections of the circle. Keep it set to 0 and 360 if you want a full circle. The alignment tool aligns the clone's shapes to the axis of the circle. With this turned on, they'll all be pointing inward at the same relative direction to the center, instead of all being rotated in the same relative direction to each other, like shown here. The axis option changes the direction of the circle. So when set to X, it'll lie flat like this. If set to Y, it'll go up and down like this. And if set to Z, it's going to face us side to side. Finally, you can move the position of your circle left and right, up and down, and forward and backward. As you can see, the base is now off-centered because the positions are set to different settings. The same thing is true with rotation. They will all rotate together, front to back, side to side, and left and right. If alignment is set to no, they'll all rotate perfectly together and will look the same from any angle. And with alignment set to yes, they'll rotate inward and outward in relative position towards the center and with each other. All of the radial clone settings can be animated or changed from state to state, except for the type, base, axis, and alignment settings. Our next cloner is the linear cloner. The linear cloner is the default cloner setting. This cloner makes a line of cloned objects. You can change the count up and down to add more or less object clones to your linear cloner. The base setting with the show and hide options dictates whether your cloned shape is visible in the scene or not. This change is not visible in the linear cloner option because your base object and the first clone are actually located in the exact same position. You can change the position of your linear cloned shapes on all axes. You can move them left and right by changing the X setting. You can move them up and down with the Y setting, and then back and forth in perspective towards and away from you with the Z setting. The scale setting in your cloner multiplies by itself with each new object. So if we set the scale for 1.2 on each axis, each shape that you see is multiplied by 1.2. So the first shape will be 1.2 in scale, the next one will be 2.4, the next one 3.6, the next one 4.8, 6.0, and so on. The rotation setting works the same way and multiplies by each shape. So if you set the rotation to 10, the first shape is going to rotate by 10, the next one by 20, the next one by 30, and so on. If you do 20, it'll be 20, 40, 60, 80, etc. That's the linear cloner. Our third cloner option is the grid cloner. The grid cloner creates 2D or 3D grids of clone shapes. It's similar to the linear cloner, but with 3 axes or dimensions instead of just 1. The base works the same way as it always does. It shows and hides the original object that's being cloned. For the grid cloner, there's a count for X, Y, and Z axes. Right now, it's 3 by 3 by 1, which makes a grid of 9 shapes, 3 tall, 3 wide, and 1 thick or flat. If you change the Z count to 3, there will be 9 shapes in a cube that's 3 by 3 by 3. You can change all 3 of these numbers to whichever to make whatever size grid with whatever proportions you like. We can change the size setting to move them apart from each other, like sideways and up and down. The use center option changes the original shape from the outside corner of your grid to the center of your grid. I usually prefer to have my original clone shape in the center. Our final cloner type is the object cloner. This cloner is unique as it creates clones of a certain object in relation to another. Delete the shape you've been using for the other cloners. We're going to make a sphere and reset its position to the center. I'm going to teach you guys how to make my signature sphere really quickly. Add a normal map and then set the sides of the sphere to 12. Then click the flat option in the visibility settings. This is the flat colorful sphere that I use for my logo and in a lot of my animations. Now what we're going to do is make a tiny little cylinder like so. Bump up the corners of it and add a fun color to it. So for this last cloner type, the object cloner, what it does is aligns your cloned objects to another object. With your cylinder selected, select the object cloner setting. Then you're going to go down where it says object and you're going to select the sphere. You can already see these tiny cloned cylinders sticking out of our sphere. As you add up the count, it starts to be sprinkled all over. What the object cloner does is it puts all cloned shapes attached to the outside of another object. You can select the spread to be random or not. Polygon, center, edge, or vertex are all the different settings. If you change the axis of each one, you can do different things. This setting kind of looks like the pinhead mask, but this is what the object cloner does. It aligns a certain object and its clones with another object in many different ways. You can select to hide the base, and you now have a cloned object on another object. You can change up all the positions so they're off kilter or off-centered from the object in any way you want. You can change the scale up and down as well to create different sizes and change the rotation so they rotate in different directions as well. The object cloner is full of options and is very complicated. Even I don't have a full knowledge of all the different ways that it works. But as always, the best way to learn is just experiment with it as much as possible, and the more you'll start to understand exactly how it works and what you can do with it. This could be a good way to add sprinkles on, let's say, a strawberry donut, but this is Spline and not Blender. There you have it. Those are the 4 different types of cloners. I'm going to quickly put the settings and description of each cloner tool on the screen for your reference. You can pause the screen to get an overview of each setting from each tool. Try experimenting with different cloner tools on different shapes and settings and see all the variations that are possible. We're almost through this lesson. There are just a few more features in cloning that are important to learn a little bit about. The Convert to Instances button at the bottom of your cloner tool settings is one of them. This is how you take all your cloned objects and turn them into real individual objects, which you can keep grouped or detach from their base object and other clones. All cloner types have a randomness setting at the bottom that can be turned off and on to apply the noise equations like purlin and simplex to your clones. This randomizer tool can help you achieve more organic, misaligned, and imperfect applications of the cloner tools. It's a fantastic way to create large sets of similar objects that behave both individually and as part of a whole. For example, you might use the randomness cloner tool to create animated grass in the wind or scattered stars in the sky with different sizes in a seemingly random pattern. Position, rotation, and scale can be randomized in purlin or simplex. The strength setting affects the power and can be moved well above 100. Seed changes the application of the noise, and the movement setting moves the location of the noise in relation to the clones. You can see me here experimenting with the randomness tool applied in different ways to a grid cloner on a set of spheres. Try experimenting with the randomness tool and linear, radial, and object cloner tools as well. Here's a reference for the randomness settings as well. Finally, if you're like me and love to animate in Spline, it's important to know that the majority of your cloner and randomness settings can be changed from state to state. Animated cloned objects can create some awesome geometrical patterned animations when changing between altered states. Here are some examples of different perfect patterns and designs you can create and animate in your work. Animations and state changes can be applied to the base object, to the cloner settings, and the randomness settings as well. Experimenting with cloner animation is a ton of fun, and I highly recommend it. That's it for lesson 1.19 on cloners. Cloners are a very complex tool and can be used in a huge variety of ways. We will learn more about them in future lessons, but until then, experiment with them as much as possible. You'll discover endless applications of this tool. The more you practice, the more its versatility will reveal itself to you.
This is lesson 1.20, Intro to Interactivity, Buttons, Targets, and Mouse Events. Number 1 is a simple button. First, we're going to make a simple button that changes color when you click it. Create a circle in your scene and reset its position. Remember, this circle could be any 2D or 3D object at all. I'm just using a circle because I'm kind of boring. Set it to a fun color and add a new state. Now set the new state to an opposite color. Now, click to add a new event to your circle and change its type from start to mouse down. This makes the event occur when you click on the object instead of when the scene starts. Set the trigger to this object and then add an action and select transition. Change the mode from once to toggle and change current to base state and set the time to 0.5 or half a second. Now press play. When you click your button or circle, it should change color and then change back each time you click it. This is how you create a simple interactive object or button in your scene. Number 2 is a toggle. Second, we're going to make a compound button that has 2 or more changes when clicked. This toggle slider is made from the button that we just made. It changes color and moves. Select your button and change its base state X position to -300 and its state X position to +300. Now create a skinny rectangle and reset its position. Change its Z position to slightly negative to set it behind the circle. Change your rectangle's color material to a gradient. Set the left color to your button's first color and the right color to its second color. Now your toggle should be ready with the same mouse down event we already added. Hit play. Your button should still change colors and it should slide back and forth on the slider at the same time. This is how you create a compound interactive object or a button that does multiple changes at once. Our third and final build will be a button that targets another object, creating a change elsewhere in the scene instead of in itself. Create a wide rectangle and reset its position and move it upwards a bit. Add 2 states to it, state and state 2, and set each state to a different color. Now create a circle for the button, reset its position, and move it down below the rectangle. Make your circle the same color as the rectangle's base state by using the eyedropper tool. Add an event to your circle button and change the type from start to mouse down and set the trigger to on this object. Add an action and select transition. Set the target to your rectangle. This will make the button change the rectangle instead of itself. Set the mode to repeat each time. Set number 1 to current and number 2 to base state. Current ensures the transition starts from whichever state the rectangle is in. Now select your rectangle and set it to state. Right-click your ellipse and duplicate it. Move the duplicate to the left below the rectangle. Change the color of the new button to match the state color of the rectangle. Go to the new button's event and make sure the target is set to rectangle and change number 2's setting from base state to state. Now repeat this process again. Set the rectangle to state 2. Duplicate your left button and then move it to the right and set its color to match state 2 of the rectangle. Open its mouse down event and change number 2 to state 2. You should now have 3 colored circles beneath a rectangle. Press play. When you click each button, the rectangle should change colors to match the color of the button. To use these techniques in your work, understand that your button can be any 2D or 3D object, or even any light, group, or camera in your scene. Now you can imagine this rectangle was perhaps a t-shirt changing colors on a web store. This is a fun way to show different colors or different styles in an interactive way. What if I told you that with one click of a button, you could turn your spline creations into this, or 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 this. Hey Spline gang, Connor here with the Motion Visual. Welcome to Spline, the Complete Guide. This is lesson 1.21, AI Style Transfer.
Style transfer is a fantastic and fun little tool that is similar to other AI image generation tools like Runway, Midjourney, ChatGPT, and Google's new Gemini tool. And there are a series of styles or visual themes like basic, anime, steampunk, kawaii, Van Gogh, watercolor, and even Minecraft that determine the image's final output. I know it's been too long since the last lesson, and I'm sorry about that. I've been learning shape blend and particle emitters well enough so that I'm qualified to teach you guys about them. Here's what I've been able to accomplish so far. Shape blend has been incredibly fun to learn, and I'm thrilled about what I've made with it so far. These animations are some of my favorite ever. Particle emitters are even more complex and are capable of creating liquid, sand, glitter, weather patterns like rain, snow, and tornadoes, and so much more. The smoke that opens the Spline Guide lessons was made with particle emitters when I was first learning them, so those lessons are coming very soon. I'm also starting Chapter 2 of this guide, which deals with external tools that you can use with Spline. Their first tool is going to be Adobe Illustrator. Don't worry, Chapter 1 is far from over. I'm going to show you how to set up style transfer and use it in its most basic way, and then we'll get a little deeper into the weeds. First, open a Spline build that you like. If you don't have one, remix one of mine in the Spline community. Get your perspective into a view that you like for an image. I have the depth of field effect on this car. Click the 3 stars next to the plus sign in the top menu and select Style Transfer. Now select any of the styles and wait. This first image is just a basic one with no settings changed. These other ones have different prompts, settings, and styles added to them. These are the basic settings for image generation. Seed is a number between 1 and 100,000 that generates an image in a specific way. You'll notice when you leave it the same, your images will have commonalities even when all other settings are changed. Prompts dictate your image generation, kind of like when you use ChatGPT, but for images. You can type full sentences, but I found that typing single descriptive words with commas between them works best. Styles are the presets we discussed earlier, and modifiers are descriptive keywords you can toggle on and off. I found I experienced bugs when using these, but I might just have too many spline animations on my computer. Change your seed number manually by typing or by pressing this randomizer button. Apply prompts by describing anything. I wrote, place the scene in an Arizona desert with lots of cacti, and I got this beautiful image. Next, I asked it to make the car purple, and it came up with this one. These are both in basic style. Try different styles by clicking any of these images. And test your luck with modifiers by opening this panel and toggling on or off any of these options. See if you have more luck than I did. Now for the more advanced options. Exclude is like a negative prompt. Type things you don't want to see in your image here. Precision is how specific the image will be to all settings. Higher settings will take longer to generate. The style setting dictates how much your image will take on the selected style. Variance is how much your image will look like your actual scene. High variance doesn't allow for much change or creativity, while low variance will make the image unrecognizable to your scene. Finally, modes are how the generator intakes your scene. Outlines uses outlines it sees in your image. Edges uses a mix of those outlines and shadows and light. And finally, shapes uses a 3D normal map for generation. I found I preferred shapes the most. This is what your style panel will look like. Change the seed number to get different styles of generations. Add your prompts where it says add more details. Like I said, single descriptive words with commas in between them tend to work best or better than sentences. Change between the styles and modifier panels to add different effects and hit the generate button when you're done to start the process. This is what your advanced settings panel will look like. Use exclude to type in words and things that you don't want to see in your image. Raise precision to get your generation closest to what your settings ask for. And raise the style setting to get it closer to the style that you selected. Raise and lower the variance to get it closer and further from your 3D scene. Finally, modes are how the generator intakes your scene. Here are some examples of my favorite car generations, along with the settings and the prompts that I used. This one is in the basic style, and I told it to make it rainbow and pastel and neon and use as many colors as possible. For this one, I turned most of the settings to medium and told it to give me a medieval European castle type of look. This one is obviously in the Van Gogh style, and I used my prompts to exaggerate that. I told it to make it nighttime and use only blue and yellow, just like Van Gogh's Starry Night. For this one, I told it to place the car in a city and add lots of graffiti. This is another example of the rainbow generation one, just with a different seed number and in basic style. I got this snowy surprise by telling it to make it nighttime and use white, blue, and yellow. This is definitely one of my favorites. And here are a bunch of my other favorite car generations that I made. As you can see, really anything is possible with the right settings and prompts. Before we finish up, I'm going to quickly show you some of the other scenes that I experimented with. This tool is really all about experimenting with the prompts and settings and using trial and error to get closer and closer to what you want. And have fun. The more fun you're having, the better your results will be. It's only a matter of time before we'll be able to use this tool on animations, and surely there are tools out there where you can already do this. So mess around and try all the different settings and styles. To save your images, just hit export and click image at the bottom of the left menu to save it. This is lesson 1.22, Shape Blend, part 1. Shape Blend is an awesome, powerful new tool that was added to Spline somewhat recently. It allows you to blend and combine the geometry of shapes together with a liquid-like effect, and is great for animations. I'm still learning to use this tool, but here are some clips of my favorite projects that I've made so far. I'm going to teach you what I know about how to use it. We'll skip the long intro today since it's been so long since the last lesson, but take a second to hit the like, subscribe, and share buttons for me if you want to help support this guide. It really does make a big difference. Now let's dive in. We're going to start this lesson by creating a new 3D design file. Get rid of the gray square, add a fun color to your background, then click the plus sign in the top menu, scroll down, and select the Shape Blend option to add a shape blend to your project. A gray sphere will appear in the middle of your Spline project with a cube outline around it. If you click isometric in the bottom viewpoint settings, you'll be able to see the surrounding box a little better. A perspective viewpoint will also show the angles of this box. This box outline marks the outer perimeter of your Shape Blend object. All shapes that are part of the Shape Blend must be within this perimeter to be visible. As you can see, if you take your gray sphere and drag it to the outside of the perimeter, it will start to be cut off and disappear. Now let's spruce up this boring gray sphere by adding some color and materials to our Shape Blend object. With the Shape Blend selected in the left menu, you can adjust the material settings. You can just change its color if you'd like, but I'm going to use this colorful matte cap from my matte cap library, which you can download from my Patreon for free. The link is in the description below. Now that we have some color, reset the position of your sphere to the center of the Shape Blend box and try enlarging it a little bit. Take a look at your left-hand menu. You will see you have the option to select your Shape Blend object or the sphere within it on the left side. Think of the Shape Blend object as a kind of group which holds all the objects within it. Click Shape Blend and notice the settings that appear in the right menu. Under the word shape, you will see settings for resolution, blending, and color. The resolution setting can be set to low, medium, high, or very high. The higher the resolution, the smoother and cleaner the 3D and animations will look, but the more computing power it will take up. The blending setting dictates how strong the blending between shapes will be. We will cover that in just a moment. Finally, the color setting gives you two options, material and children. When material is selected, all objects within the Shape Blend object will have the same material. And when children is selected, you will be able to adjust the material and color settings of each object individually. Now let's try adding a second shape to our Shape Blend box. Click the sphere object in the top menu to add a second sphere. At first, it will look like your original sphere has grown, but this is just the effect of your two spheres blending together while in the same centered position. With your second sphere selected, try dragging its position downward. You will see your new sphere slowly start to appear, and there will be a liquid-like connection between the two spheres as you drag them apart. Once your second sphere is far enough from the center, this connection or blend between the two shapes will separate. Now click your Shape Blend object in the left-hand menu again. Try turning the blending settings up and down. You will see how this number strengthens and weakens the blend between the two spherical shapes. Great. Now let's right-click our second sphere at the bottom and duplicate it. Try moving the third sphere up above the center. With sphere number 2 selected at the bottom, go to the settings in the right menu and click the word Yes next to Blend Override. You'll notice a new blending bar will appear below. This Blend Override setting allows you to specify the blending setting for each object individually. As you adjust this setting, you'll notice that only the blending of sphere number 2 is affected, but not the rest of the shapes. Now let's learn about operations. Each individual shape in your Shape Blend object has 3 operation settings: Unite, Subtract, and Intersect. Number 1, Union is the default operation setting, and it's what allows your shapes to blend with one another by adding to each other's geometry as they come close to or contact one another. Number 2, Subtract, is the middle operation setting, and it changes the operation of the selected object to subtract its geometry from other shapes it comes in contact with. And number 3, Intersect, is the right operation setting, which will also make the selected object invisible, and its geometry will only be visible when its mass overlaps or intersects with other objects in the shape blend. For objects to be affected by the object with the operation setting turned on,
They must be beneath that object in the left-hand list. Objects above the operation will be unaffected. Objects with the union operation on will have a green shape next to them on the left-hand list. Objects with subtract turned on will be red, and objects with intersect turned on will be yellow. Now try selecting the subtract operation in the middle. Once this operation is turned on, try moving sphere number 2 up and around the center where the original sphere is located. You will see the spherical shape is now subtracted from the center shape. This is the effect of the subtraction operation. You will notice sphere number 3 is unaffected by sphere number 2. This is because of the rule that objects set to subtract or intersect only affect the shapes that are beneath them in the list. Shapes above them remain unaffected. To change this, just rearrange the list by clicking and dragging. Now with sphere number 2 still selected, try choosing the intersect operation on the right. As you move sphere number 2 around, you will notice you can only see it when it intersects with sphere number 1. Sphere number 3 still remains unaffected. Now let's try removing our center sphere and adding a new shape. Delete the sphere from the center and try clicking the cube button in the top menu. A cube will now appear in the center of your shape blend box. Each shape will have its own unique settings. As you can see, you can adjust the corners of your cube to be sharper or smoother. Experiment with messing around with the position, size, rotation, and blending of your cube. Now select sphere number 2 and set its operation to subtract. You will notice that it has no effect on the cube when you move it around. This is because sphere number 2 is beneath the cube in the left-hand list. When you rearrange the list to put sphere number 2 above the cube, you will instantly see its subtraction effects. Try moving its position around and adjusting its size to see what different effects you can make. Now let's go back and start fresh with just a sphere in the middle of our shape blend object. We're going to try experimenting with the torus shape this time. The torus has its own settings that allow you to change the size, width of its tube, and slice or rotation by degrees of its circle. When you first add the torus to your shape blend object, it will be combined with the sphere in the center. Experiment with the settings until you can create a ring around the sphere, almost like Saturn, as you can see on the screen now. If you have trouble, just copy my settings. As you move the torus up and down, you will see its top and bottom combine and break away with the sphere in the center. Next, we're going to experiment with the cloner tool within the shape blend object. The cloner tool offers all sorts of different options for you to experiment and play with. If you haven't seen the lesson on cloners, definitely check it out now. I'm going to show you the basics and allow you to do the testing on your own. Choose your sphere and scroll down in the right menu until you see the cloner toggle and toggle it on. Set the cloner type to radial and bring the object count up to 6. In the left menu, click the eyeball next to your torus shape and make it invisible for now. Now adjust the radius, scale, and size settings of your sphere until you achieve 6 spheres in a circle around a sphere in the center, as I'm doing now. If you have trouble, again, you can copy my settings. Now try to click and drag the position of your sphere to the front of your shape blend box. You will see as you get too close to the front, your spheres will start to get cut off. Get as close to the front as you can without this happening. Now we're going to try making some animations with our shape blend object. Click the plus next to state to add a new state to your sphere. Set the Z setting on base state so that it's in the front of your shape blend box. Then select state and move the Z setting into the negative so that it moves to the opposite end of the box. With state still selected, rotate the Z setting about 360 degrees. Then click to add a new event, leave it as a start event, and click transition. Change current to base state, set the second settings to 4, set loop to infinite, and change the cycle setting to ping pong. Now when you click play, your spheres will move back and forth to the front and back of the shape blend box while rotating. Finally, let's click the eyeball next to our torus shape again so it's visible and try hitting play again. Your spheres will intersect and blend with the torus in the center as they move back and forth within this box. Animations are where the shape blend tool really shines. When the resolution is set to high, the blending and separating of these shapes really look beautiful. Now let's experiment with animating the torus as well. This next part of the video will be sped up, but you can slow it down in the settings if you'd like to follow along. I'm animating the torus by adding multiple states to the object and changing its size, position, and rotation in each one. Now with both the sphere and the torus animated within the shape blend box, there will be an infinite combination of different types of animations created once you hit play. That's it for lesson 22 of the Spline guide on shape blend. We'll be learning more about this complex and powerful tool in part 2. If you have any questions or suggestions, ask away in the comments below. Make sure to hit the like, subscribe, and share buttons before you go. Thanks so much for being here. I'm Connor with the Motion Visual. See you guys in the next lesson. Peace. This is lesson 1.23, Shape Blend, Part 2.
Shape Blend is an awesome, powerful new tool that was added to Spline somewhat recently. It allows you to blend and combine the geometry of shapes together with a liquid-like effect. We're going to start this lesson with a new 3D design file. Choose a fun, lightly saturated background color, then click the plus sign in the top menu to add a new Shape Blend object to your project. Now with Shape Blend selected in your left menu, go over to the settings on the right and choose the Children option next to Color. This allows you to add unique material settings to each object within the Shape Blend. Now select your sphere, scale it up a little bit, and add a color to it. Primary colors like cyan, magenta, and yellow work best for this experiment. Now click the sphere shape in the top menu to add a new sphere to your blend. You'll notice the sphere in the center grows a little bit and its color decreases in saturation. This is because it's mixing with the gray color of the new sphere. Drag the second sphere downward. You can now see how one sphere is pink and one is gray. Now add a new different color to your second sphere. Repeat this process again with a third sphere and a third color. As you begin to move the spheres around, you will notice that not only do their geometries blend and intersect, but their colors also blend and mix with one another, almost like paint. I'm going to quickly cover operations again in case I wasn't clear in the last lesson. The three operations are unite, subtract, and intersect. Unite or union is the default operation on the left, and it joins or blends shapes together. Subtract is the operation in the middle, and it subtracts the affected shape from the shapes below it in the left-hand list. The affected shape will become invisible. Intersect is the operation on the right, and it will make the affected shape as well as the other shapes below it on the list only visible when they overlap or intersect with each other. Shapes with the subtract or intersect operation applied will only affect the shapes beneath it in the left-hand list, so keep that in mind. To help you keep track, your shapes will have a colored icon next to them in the left-hand list. Unite or union will be green, subtract will be red, and intersect will be yellow. Try experimenting with these operations again until you feel you have the hang of it. Now I'll show you a fun way you can use these operations. Start with a fresh Shape Blend object with a simple sphere in the middle. Enlarge it a little bit. Select the eyeball next to Shape Blend in the left menu and make it invisible. Now we'll add a new shape to our project from the top menu. Choose icosahedron, click and drag to create it, right-click to reset its position to the center, and scale it down so it's pretty small. Now let's change its color to a normal material and add a little spice. Next, we're going to animate this shape. Add a new state to it and rotate the object in two different directions in your new state. Create a new transition event for the shape, set current to base state, set the seconds to 2, set the loop to infinite, and the cycle to ping pong. When you hit play, your shape should rotate back and forth like this. Now let's make our shape blend visible again. Add a second sphere to it, drag it away from the center, and change the operation of sphere number 2 to subtract. Make sure it is above the original sphere in the left-hand menu. Now try dragging your second sphere back and forth over the front of your original sphere in the center. You will see as the original sphere is subtracted from the second, it reveals the shape that we created in its core. This is because the icosahedron is not part of our shape blend. This is a fun little trick that you can use in lots of different ways, so let your imagination run wild. Let's try animating our invisible sphere so it goes back and forth across the centered one and reveals the animated shape in the middle. Set your invisible sphere to one side, add a new state to it, then drag it across the middle sphere so it reveals the shape when you do. Add a transition event to this sphere, set it to loop and ping pong as well. Follow the steps I take on screen if you're not familiar with this process yet. When you hit play, the rotating shape in the center will be covered and revealed as the invisible sphere subtracts from the middle sphere in a separate animation. Pretty cool. Next, let's learn how to create and model unique shapes in our shape blend. Unfortunately, 3D modeling isn't possible inside a shape blend just yet. When you attempt to create Booleans or merge geometries, the objects become unaffected by the shape blend output effect. I'm going to show you how you can get around this somewhat and create some simple, unique shapes. Create a new shape blend and add a cylinder to it. Give it a fun color and increase its height so it's tall and skinny like so, and move it off to the left-hand side of your shape blend perimeter. Now right-click and duplicate it, and remove the negative sign from the X setting on the top of the right-hand menu. It should move to the right side. Now select both of these cylinders at once, right-click and duplicate them as well, and then rotate your new third and fourth cylinder together 90 degrees so that they create a square-like shape. You can select your shape blend in the left list now and adjust the overall blending settings until you get something that you like. Finally, select all 4 of your cylinders at once in the left menu, right-click, and select Group Selection. All 4 of your cylinders are now part of a single group. When you move, rotate, scale, or adjust the materials of this group, all 4 cylinder shapes will be affected together. You can use this simple concept to create more complex 3D models and shapes. It will take some practice and experimenting, and you will need to adjust different settings to get the final result you want. but it's a great workaround for getting some more unique shapes than the simple ones that are offered. I use this technique to create this fun moondog text animation that you see now. Each letter is a group or combination of the 4 simple shapes arranged to create this unique lettering. I will make this file available in the Spline community for you guys to experiment and mess around with. Just search moondog. Now we're going to use everything we've learned so far to create a fun lava lamp type animation using the shape blend tool. On screen is a colorful example that I made somewhat recently. Start from scratch with a simple shape blend again. With shape blend selected, change your color material to matte cap. You can use the default one that Spline offers, or you can download the caps I use here from my Patreon. You can get a sample pack of 50 of them for completely free, or get all 500 for a few bucks. The link is on screen and in the description below. I'm going to use this fun glittery blue one. Now I'm going to right click, duplicate my sphere, and adjust the size and position of the new one, adjusting the overall blending settings until I get something that I like. I'm going to double the speed of this next part in the video, but you can slow it down in the settings if you prefer. I'll explain what I'm doing as I go along. For each sphere, I'm creating a unique looping animation that repeats infinitely. I'm changing the size and position of each sphere each time, being careful not to move them too far away from each other so that the shape blend effect connects and disconnects them throughout the animation. You can use as many states in your events as you like. Here I'm adjusting the different settings like timing until I get an animation that I like. This looks pretty good. Now I'm going to select both of my spheres at once in the left-hand menu, right-click, and group the selection. Now, with the group selected, I'm going to animate the group of both spheres to move up and down. Now the spheres are animated to move around both individually and together as a group, kind of like the little blobs inside a lava lamp. When I hit play, you can see this in action. For the next step, I'm going to repeat this process 2 more times using different positions and sizes for the spheres. Try rotating and adjusting the X, Y, and Z settings next to size for your larger spheres to create elongated blobs of lava in different directions for a more realistic liquid effect. Here's the final result of the individual and groups of spheres animated to move around in 3D space and interact with each other. You can even take this concept one step further by animating the entire shape blend to rotate back and forth while these animations are going on inside it. Here's the final result with that new addition. Pretty cool, right? For some finishing touches, you can try adding post-processing effects like hue change, pixelation, and aberration. If you want, you can export this animation for your Instagram, YouTube, or other social media like this. Check out lesson 1.16 on exporting for the whole process. You can also change the matte cap of your entire shape blend at once to create a whole new dynamic and style from the same animation. Here's a cool futuristic black padded fabric matte cap that I have in my matte cap library. With a simple change of material and background, you have a whole new animation in just a few seconds. That's it for lesson 23 of Spline the Complete Guide. If you have any questions or suggestions, ask away in the comments below. Make sure to hit the like, subscribe, and share buttons before you go. Thanks so much for being here. I'm Connor with the Motion Visual. See you guys in the next lesson. Peace. Hey Spline gang, Connor here with the Motion Visual. Welcome to Spline the Complete Guide. Okay, we're going to start this lesson off by creating a new 3D design file. Get rid of the square and choose a fun, lightly colored background. Now click the plus sign in the top menu and we're going to create a new shape. I'm going to use an icosahedron. Now hold shift for proper proportions, click and drag to create your shape. I'm going to rotate mine a little to give it a fun look, and then right-click it to reset its position so it's centered. Now let's change its color material to matte cap. You can use the default Spline matte caps, but I'm going to select something fun from my matte cap library. This library has over 500 awesome matte caps. There are tons of colors, materials, patterns, designs, and so much more. You can download a sample of 50 of them totally for free on my Patreon. I'll put the link in the top right now. I'm going to choose this fun shiny green matte cap. Now that it's applied, I'm going to increase my corner settings to round them out a little bit. Great. Now we're going to make another matte cap layer and choose a different looking matte cap, like maybe this pink one. Now when you turn the opacity setting on the top matte cap down, you should see it change from one to another, like so. Great. Now that we're ready, we're going to start off by making 2 different states. Click the plus sign next to states and you'll have a base state and a state. Now I'm going to change my matte cap, the pink one, so that it's invisible, so that the state switches to green. And the base state will be pink like so. Now I'm going to hold shift and scale the base state downward. Hold shift and scale
the state upward. Now we have an object that's changing color and size from base state to state. Next, we're going to click the plus sign next to events, which will be a start event by default. We'll choose transition from our actions, change current to base state, set our seconds to 3, and then we're ready with our start event, which we've already learned about, just a basic animation. When you hit play, it will go from base state to state. Now we're going to learn about interactive events, okay? Click your object, go to your event, and then up top where it says start, you're going to click the next event style, which will be a mouse up event. Mouse up events happen when you let go of up. We're going to set the type to on this object so that you have to click the object itself, and then set the mode to toggle so it can go back and forth. When you click, nothing happens, but when you let go of the mouse or release it, your animation will happen. So when you click and hold, nothing happens, but then when you release it, that starts the event. And that's what a mouse up event is. It happens when your mouse click goes up. Now we're gonna choose our next event style, which will be a mouse down event. Mouse down events happen when you click on the object. So all you have to do is click and release, and it happens automatically. You don't have to hold it. So click, mouse down, and it starts your animation. Click it again, and it goes back. Great. There you have it. Now we're gonna do a mouse press event. Mouse press events are only activated when you press and hold on the object. When you release, it goes back to its base state. So now I'm pressing and releasing. Pressing and releasing. Pressing and holding, and then releasing. Pressing and holding, and then releasing. Goes back and forth between states. Next, we're going to do a mouse hover event. Mouse hover events happen when you hover over the object. So as I go over it, it changes. As I stop, it goes back. Hover, stops, goes back. Hover, stay there, then go away, and it returns. Hover and remain over the object, then go back, and it returns. Great job. Now we're going to use our keys. These work the same way as in the mouse events, but they use keys. So we're going to select the key. I'm going to select the key A. We'll have the same transition, and these work the same way. So now when I press and hold A, it only activates when I release A. So when it's held, nothing happens. When I release A, then it goes back. A is held. Then when A is let up, our animation goes back. So only when you let the key up does this work. Key down, same thing, but the opposite. Again, all you have to do is click. You don't have to hold for a key down event. Set to A again. Click A. You don't have to be over the object, and your animation will start. Click A again, and then your animation will start. Each time you click the A key, or any key you select, your animation will start and go back. Then finally, we have the key press event. This only makes the animation happen when you're holding the key. So when A is held, it activates. When it's released, it reverses. A is being held down, then when you release it, it will reverse back to base state. See, if you only hold it for a second, it changes. The next is a scroll event. The scroll event happens when you use your scroll wheel. We're going to set the steps to 10 for our first trial right now. Now I'm scrolling the mouse forward to 10, and then scrolling it backwards, zooming in and out, scrolling it forwards, and then scrolling it backwards, scrolling it forwards, and then scrolling it backwards. Now if we change our steps to 5, you can see it happens much quicker, barely zooming in and out, only 5 steps on the scroll wheel. And again, if we change it in the other direction to let's say 40, it takes a lot longer. This is 40 steps on the scroll wheel in, and then 40 steps back in the other direction. Great.
Next, we have a drag and drop event. This makes your transition happen when you click and drag and move your object around in the scene. So we have to set our transition again on drag and do the same thing. Base state, set it to 3 seconds. Great. Now when you drag your object, it will change transition. And when you drop, it will go back to base state. Drag it. Drop it. Great. The next is a lookat event. These don't have the transitions between states, but if you set it to look at, our target's going to be the cursor, and our object will look at the cursor as it moves around in our scene. So when I hit play, as you can see, our shape is kind of looking around at wherever our cursor is on the screen when you move it around. The next event is a follow event. This is going to make our object follow around or actually somewhat become our cursor, which is the target in this case. As you can see, now when we move our cursor around, our object is our cursor. This can be great for making websites. If you want, you can increase the dampening on this so that there's a little bit of a slow down thing going on when you move your mouse around. As you can see, now the shape's kind of trailing. If we move this up even more, the trailing will take much longer to occur. I have a bunch of tutorials about this cursor following event, so definitely check out those videos if you're interested in this. Those are the first interactive event and action types. The next is going to be game controls and a bunch of more complex advanced events and interactions. So these first 12 are just going to be the only ones that we cover today. But these work on all different styles of animations that you can imagine. So experiment with them. They're fantastic, again, for website building, for building basic games and apps. All of these different events are interactive events. So again, the animation we learned already is a start event, which just happens when you hit play. And all of these are interactive events like we just learned. Beneath these are all actions. We used a transition, which is our basic animation. And there's going to be a bunch more advanced actions as well, which we will learn further along in this guide. But these are the basic events and interactive transitions that you can use on all your animations in Spline. So I hope this was helpful. Again, you can do any kinds of animations. So here I'm going to add a rotation to my state, and we'll also move it down, and we'll move our base state up. And now we're set to a mouse press event at the moment. We'll set it to a key press event, set up our transition the same way that we did. We'll set our animation to loop and cycle, ping pong back and forth, and we'll set our key to A again. Then when you hit and hold A, all these different types of animations are going to happen between your base state and your state. So as you can see, any type of animation that you can imagine is possible. The only thing you have to think about is for things like mouse hover and mouse press, when your target is on the object and not the whole scene, you have to make sure that you're on top of the object the entire time, or it won't work. Here, as you can see, I'm pressing and holding the key, and then pressing and holding it for shorter and longer periods of time. All right, great. That's going to be it for our basic interactive event animations. Thanks so much for being here, guys.
Make sure you smash all those buttons for me before you leave. Let me know what you want to learn next in the comments. Sign up for a free one-on-one lesson and turn on your notifications so you don't miss the next one. I'm Connor with the Motion Visual, and I'll see you then. Peace.